That's it. We
World's
are
best
live.
investigator.
We are live. Today is Friday, the 19th of October, 2018. Astral, Patricia, and Mr. Thrive and Survive. Rich, good evening.
Hello,
Good
everyone.
evening. Hi, Rich. Nice to see you again. Rich, I have to apologize to you, brother, because you put a post, you did something, and I called you a coffin dodger.
A coffin dodger?
Yeah, a coffin dodger. You know what a coffin is?
Yeah, I know what a coffin is.
Yeah, exactly. You're a coffin dodger
What does
because
that
you
mean?
cheated death. I
Oh,
am too.
okay.
Yeah, don't take it in the wrong way. Take it light-heartedly, please, brother. Light-heartedly. Understand? Love that.
Oh, no, it takes a lot to really offend me. So, no offense
No,
taken.
no offense meant anyway.
Yeah,
You know
yeah,
that.
I wouldn't think
Love
so.
you.
No. Hey, everyone that's in the chat, I want to make today your questions have a higher priority. So if you all want to throw some questions at me or whatever, uh, I'll do my best to try to answer them if I can.
Okay, you know that takes a couple of minutes to sort of seep through, but you've been putting some videos out, haven't you, Rich? You've been putting out water physics, and you've been putting out the Earth spin, fail.
Yes. Earth spin fail is that's the latest that shows unequivocally that the straight up model of things should get heavier as you move towards the poles is not true. They tend to, but there's exceptions, and there shouldn't be any exceptions. A lot of people, when I first did my spin tests, for those of you who don't know, it's simple. I got the idea from someone in Australia who was trying to prove that the Earth spins. He's a globe earther, and he went from Perth to someplace else in Australia. I think it was Sydney, and he got a scale online at Amazon, and he got a 500-gram weight. And this scale in particular allows you to calibrate it. So wherever you are, which is excellent, it allows you to have a fixed reference point where you are. And a lot of people were complaining, saying, "Oh, the scale's not accurate enough, the weight's not heavy enough." But hey, this guy did it to prove that the Earth was a spinning ball, and he noted a difference in the weight, and he said that yes, when he moved towards the equator, the weight weighed more, and that's absolute proof that we live on a spinning ball. So I said, well, let me try this. So I took from Arizona, which is the 33rd degree parallel, and flew to Baltimore, which is the 38th degree parallel, and then went to upstate New York, the Schenectady area, Albany, and that was 40 something degrees. And then I went to Chicago, and each one of those places, I took the scale out and the weight, and I measured everywhere, and there was a difference everywhere. There was also a variance everywhere. For example, in Phoenix, when I did it, I calibrated it to 500 grams specifically, and it remained that way not long, actually. There was a variance higher and lower each day, which I think is probably air pressure, but it wasn't much. It was a 0.08 grams difference. So my low figure was 499.92 grams, and the high figure wasn't quite that high. It was 500.04, I think. So there was a variance, let's say plus or minus 0.08 grams. And I did that, and I did a video showing that Chicago in particular was off. In fact, you know what? I'm going to pull that up while I'm talking to you, the spreadsheet I used. And because I think it's important, because what I want to do now is talking to somebody in the Seattle, Washington area. He's given me an idea how we can expand this. What happened was, of course, because it didn't match what the globe earthers say it should match and what science says it should be for the Earth. They said that it was invalid for different reasons. I wasn't doing the right thing. And so, of course, I didn't know what I was talking about, so I couldn't get the right answer. And Let me share. Taking care of the link.
Broken up here a bit. Was it just me?
I don't know. Can you hear me okay? Oh, Karen's muted.
Oh, yeah, a bit.
Me, I thought my computer was freezing. It was you that time, Rich.
A little bit
Is
fragmented.
Everything okay now?
I
Yes.
can hear now, yeah.
Okay, I'm going to share. It's okay.
Yeah, you take the link
And,
out, don't you?
Absolutely. Won't let me share. Let me try again. Will not let me share.
Yeah, I've had that problem, Rich.
Really?
I
Okay,
can't share.
what'll happen is I click on share and it just sits there.
Yeah, same with me.
I'll give it a few seconds. Maybe it's doing something in the background.
Because the CIA and the NSA don't want us sharing things on here. Simply
Yeah.
because of that.
Well, what I'll do is maybe I'll leave the Hangout and come back in. Would that be okay, Karen?
Of course, Rich.
Alrighty. Well, because I want to explain this because it's important because we need volunteers to help bring this to a greater realization. Yeah, this isn't working. So I'm gonna end this, come back, explain it again. I should be no more than 60 seconds, and then we'll continue on.
Cool.
Okay.
Should we say hello to the chat room, Karen?
Well, it was just me with the sharing. I don't know how you add it on. There's no tool thing, and I don't know what's happened there. Yeah. Hello, chat room and everyone. Yeah, there he is, already back.
Yeah, it didn't take too long, did it? Now let's try it. Oh, you know what I think the problem is? I got to open this in Google Chrome. All right, I'll be back again.
Oh, is that the problem?
I'll bet you it is. Watch. I'll be back.
Oh, okay, that might be right because I'm not in Google. All right. Okay, well, I'll be doing it through that and try it next time then. So, yes, good evening, chat room. There's Dragon. There's
All
John
righty.
Watson, see Oddity, Astral's in there, Anton, AJ Morningstar, Haozang, Leah, Joe Mama.
That's it, Karen.
Really?
Dave Marsh,
Oh,
Nimble Horse,
yeah, keep going, Astral.
Rob Kine, Dawn's in there, NJ Jeep Girl. Blah, 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 blah. Did I say Nimble? Yes, I did. Truth Seeker.
Nimble Horse,
Yeah,
Sheep,
hi to everyone.
Mwah.
Sheeps and
Jay.
Neeps.
Mwah. Jay.
AJ
Woo.
Morningstar, Anton Musa. What's that? Into Musicable.
Oh, yeah, hello. Hey, Rich is ready now. Oh.
All right, let's listen to Rich
Reggie,
again.
you calling out the people that are here?
Yeah, Ricky. Jay Sum.
We'll do some shout outs later as well.
Let's be practical. Rich. Another Rich.
That's the best name, huh? Okay, can you see my screen?
We can see your screen.
All righty. So just for those who haven't seen the video, hopefully you can see the cursor here. I live in Phoenix, which is roughly here, 32nd latitude. So here's 30 degrees, 31, 32. Actually, I'm at 33, and everybody says, see, you're a Mason. It's like, I can't help where I live. I didn't put the numbers on the map. They did. So most of my travel, see, I went from Phoenix over to Baltimore here. Is the cursor visible?
Yeah, it is.
Okay.
Yeah, it is, yeah.
All right. So, but, according to the Earth spin theory, it doesn't matter east and west. That doesn't matter at all. It's north and south because as the theory goes, you're spinning at 1,080 miles per hour at the equator and 0 at the pole, which when you really think about it, it's impossible. But the centrifugal force that is created from that spin, and this isn't me talking, this is actually mainstream science, and in particular, where I got this idea from is, I've been into precious metals, gold and silver, and the Bank of England and the different people that do establish the official weights for coins and bullion bars and things like that. They put out a statement saying that there, for example, a one gram bar of gold weighs exactly 1 gram if you're at England, if you're in London, England. That's how it's all calibrated. And then they say if you're in Ecuador, it should weigh this much more. And if you're in, I don't know, northern Nova Scotia, or even in, let's say, southern New Zealand, it should weigh a lot less. No, relatively a lot less. I mean, 1 gram is 1 gram, but that applies all the way up to all different weight scales. So again, I got a 500-gram weight and a scale that could be calibrated. So I calibrated it to be exactly 500 grams at 33 degrees latitude. And that's equivalent of being right here on the East Coast. I then flew to Baltimore, Maryland, which is here roughly 38 degrees. I'm sorry, 39.4 degrees is Baltimore right here. I then went to Albany, New York area, and that is 42.7 degrees north. And then I flew back to Chicago, which is, believe it or not, and this really worked out nice. Chicago's right here, right next to the lake. It is almost equidistant between Baltimore and New York. I mean, it almost splits it perfectly. So it was kind of a neat kind of thing that happened by accident. I didn't want to go to Chicago, but my flights had to do that to get back to Arizona. So at each location, I did weigh not only this 500-gram weight, but I also took a 10-ounce silver bar with me. And the reason why I did that was because that's a non-metallic object. I wanted to take out magnetism from the equation. And honestly, I haven't really gone through that part of it yet, the silver part. I got to plug those numbers in and see how they work out and see if they differ. But what I would expect is, actually, let me show you exactly which is, let me give you the problem first. What I did was I noticed that Chicago, right here, and I listed these from the farthest south to the farthest north: Phoenix, Baltimore, Chicago, New York. And again, it's not New York City, it's upstate New York, Albany, New York area. There's some confusion that happens with this. And I put the weights in, and here are the predicted weights. Now, the way I did this at first was I took the Phoenix to Baltimore weight and I calibrated the difference. And I found that, okay, that's, I think it was six degrees difference, or point per 6 degrees difference, or per 1 degree difference, you should have this much weight difference. The exact number doesn't matter. But what I did was I just did a simple extrapolation. If I went from 33 degrees to 39 degrees and the weight changed from 500 grams to 500.17, then how much more would it change if I went another so many degrees north? So, and that gave me, when I first did this, actually, just eyeballing it before I got back and put it into a spreadsheet, I was like, wow, there's something to this, because it actually does appear that it's going along with the spinning ball. However, when I got to Chicago, it didn't fit the mix anymore. And later, after that, when I plugged everything in, none of the equations were right, the assumptions that I made. But of course, you get all the flack. Hey, you're stupid because you extrapolated, and this is not how science says to do it. So I found a spreadsheet online which tells you exactly how to do it with all the formulas and everything. And what it comes down to is science says there are two figures that are necessary. One is your latitude, north or south from the equator, and your altitude above sea level. Those are the only two factors that you have to consider, and then you can get exactly what a weight should weigh from one location to another. So I was thinking, well, maybe that's what it is. Chicago was maybe higher up or something like that, and that's why the numbers were wrong. So I plugged all those numbers in, and believe it or not, I was extremely close, even just by eyeballing it and extrapolating, which goes to show, see, people are so brainwashed, they don't realize that you can think for yourself and come up with your own extrapolations and your own ratios to proportions and things like that. But no, they think if a PhD didn't write it, that you got no business talking about it. So I took the PhD's papers, and what I did was I calibrated everything to Phoenix right here. See if I can actually make this bigger. Didn't want to go that far. I don't know what's going on here. See, this is caused by the spin of the Earth. Wow, we're gonna have to exit that out. I don't know what the heck I did.
Aw.
Isn't that something? Wow. All that, and it's back to here. Let me go a little bit larger. Am I still broadcasting? Okay.
Yeah, you're perfect.
All righty. All right, so here we go. Now, the blue bar here is the calculator I used online, the scientifically approved, PhD approved, peer reviewed calculator on how you're supposed to calculate weights. So I calibrated all that to Phoenix, and so you see they match perfectly. Now, when I did the video, I couldn't remember what I did here, but the reason why these bars match, I took the weight and divided it by 51, basically, so that the pie chart would be in proportion. So with that being said, Phoenix, as you can see, matched up perfectly. The blue is the predicted weight at the location, and the reddish type of color here is the actual weight of the object. So again, Phoenix was the base. So then I flew to Baltimore. Now, Baltimore, according to the latitude and the altitude that I took the observation, and I actually took altitude readings at each location when I did it. And that was built into, I was doing the other thing with the Theodolite app, if you remember. And I have an update on that as well. My assumptions were correct with that as far as relative position, but that won't make sense to people unless I get into it. But Baltimore was predicting that I should have a weight up here. But look, this was the actual weight in Baltimore. It was considerably lower than what was predicted. And granted, this is with a very light weight, 500 grams. But just imagine how much off it would be if you used 2 kilograms or something like that. So anyway, so Baltimore, it did follow what it should as far as just if you just blindly said, hey, Baltimore should weigh more because you're moving away from the equator. Yes, that's true, but it should be weighing more than it actually did. So then I went to New York, and because I'm moving even that much farther north, you could see that the weight should have been this much heavier. And it wasn't. It was still lighter, but look, it's closer than Baltimore. So that's interesting to me that not only is it off, but it's off by less. Now, here's the big one. Chicago, as you can see, should be in between Baltimore and New York, the blue we're looking at here. And like I said, the degrees of longitude are so close, it should almost be exactly, but I had a different altitude when I did the measurement. So it's a little bit skewed towards New York, what it should be. But look, in Chicago, it actually exceeded the predicted for the first time. So to me, there are some factors that we're not looking at. Again, science says just take a look at the 2 factors I said, altitude and longitude, and that will give you an accurate reading. Now, when I repeat this...
Can I just add, it might sound stupid this, but the days that you took those readings, how was the temperature? Because would that not have a bearing upon things? You know,
yes.
Okay. I'll let you talk, man. I just wanted to put that in because I'm thinking.
All the weights, everything was taken indoors, so it was pretty much within, I'd say, 2 degrees, 72 degrees to 74 degrees Fahrenheit. So it wasn't done outdoors. So we didn't have that to deal with. And you would assume that the humidity inside would be relatively the same as well. Now, when I did this, it was in July, which is very humid on the East Coast. In fact, it was raining in Baltimore many of the days I was there. Not every day, but every morning I still did the weight, and there was some variance each day. But and you're right, the temperature and in fact, this is a good segue. I'm glad you brought it up. Air density is determined pretty much by 3 things. There's other little, very minute things that go into it too, but they're so minute it doesn't make any sense to even consider it. Those are temperature. What is the current air temperature? what is the humidity, and I'm talking about more specific humidity, different than relative humidity, and I'll explain how that's ascertained in a minute, because this is going to pertain to the Soundly photographs and things like that, and the observations I'm going to do there. And so what you're actually looking for is how much moisture is in the air, and the temperature, and the barometric pressure. And I think that actually should be the standard for anybody now that's going to be doing flat Earth videos, where you're going out and looking at some distance and saying you can see something with those figures. And the barometric pressure, your local barometric pressure, you can actually get an app on your phone which tells you your exact barometric pressure, exactly where you are.
Can I just say something again?
Sure.
You've hit the nail on the head there, in a sense, I believe, because barometric pressure, you would have to have the same barometric pressure to get the same. I mean, let's take, for example, you're looking through a P900 or a P1000, you know, this camera. If you've got 1,000 millibars, or if you've got 1,050 millibars, what would the difference be looking through that camera? Do you understand what I'm saying, Rich? You're a weatherman, or you've got knowledge of that more than I do anyway, that's for sure. But it certainly must have some sort of a bearing, a significance upon what your readings are, what you're viewing, because we've got a difference in barometric pressure. Now, if they're the same pressure, you know, when you do the measurement, reading, recording, whatever, experiment, then, okay, it can be verified, can't it? Because it can be checked against the opposing. You know, if you've got 1,000 here and 1,000 there in another city, then obviously we should be seeing similar things, right? I yield the floor. I've spoke too much now.
Yeah, no, that's good. The barometric pressure, like I said, that's one of three components to tell what the air density is. With the claimed refraction that the ball earthers want to use, and I've covered this in my videos using Snell's law, it is the density of one medium to another, like sticking a spoon into a glass with water and watching it bend, or a straw, whatever object you stick in there. It is the density change of the material that you're looking through, which makes the difference. Now, barometric pressure is one aspect of that, but just to give you an idea, let's say you're shooting across a 25-mile lake, like in Louisiana, Lake Pontchartrain. The barometric pressure where you're located and 25 miles away may be 2 millibars different, believe it or not. I mean, it's just not that much of a difference over that small of a distance than people think. There's going to be a lot more variation in humidity and in the actual temperature, which are the other factors that go into this. Barometric pressure is important to calculate the overall density, but you're going to be surprised how little your barometric pressure is going to be versus the observer, let's say 25 miles away. In fact, I can remember charting and, you know, being 200 miles away and the barometric pressure is virtually the same. Now, it can be different, but in those cases, you're usually not doing observations. For example, if you have a strong cold or warm front going through, or you're very close to some sort of passage of a low or high pressure near your area, then you can get a condition that's called pressure rising rapidly or pressure falling rapidly. But these are rare instances, and when they happen, because of that, you're going to have inclement weather, and chances are you're not going to be doing long distance observations anyway. But with Snell's law, again, going back to its density and the angle that you're looking at. Now, when I remind me of that, because when we come off of this spreadsheet, I want to talk about that, because there are some things that are coming out right now and will be coming out in the next year or two that I think it's going to be almost impossible to claim sphericity in the globe, or a globe period. We're going to be able to totally just blow it away. People are coming out with mathematics. I don't know if you've seen it. Yeah. Have you seen any of these people that are coming up with, I mean, geniuses? These are engineers, science majors, who are, I mean, the data's been there all along, or the formulas, and of course we don't know it because nobody teaches it. But if you're, for example, and this is very exciting to me, if you're looking 10 miles away over water and you're 6 feet off the water and you're looking at a target that's 6 feet off the water, on the other shore, 10 miles away, or no, let's put it this way. A boat is 10 miles away, a sailboat, and on the water. And of course, we know now about refractive mirroring, or just mirroring of people have seen these now. Hopefully the windmills, they look like when the arm of the windmill goes down towards the water, it actually looks like an arm from the water reaches up to touch the windmill. Well, that's a reflection. It's a inverse I can't remember the term they used. It might not even be the professional term, but there's an inverse refractive index that happens over water where you get this mirroring effect, and the actual eye level that you think where the ocean is or lake, whatever, is actually higher up because of that mirroring. But there's actually in science, they're not that complex even. These formulas that say, okay, if you're looking out 10 miles and you're looking at a boat and you plug these numbers in, it'll tell you exactly how much of the bottom of the boat will be gone from your sight, not from curvature, but from this normal refractive mirroring. They've known about this forever, and yet it's not taught. But some of these engineering geniuses have put together a formula to say, hey, if you're looking at this 12.5 miles apart and this are the conditions, and you're looking through a camera that with a 32 millimeter focal length or whatever, I'm not a camera person, so I might be saying wrong stuff, but whatever, it'll say, okay, 7.23 feet of the boat will be hidden because of this refractive whatever. It's just genius work. And it explains exactly what we see. And it's done it's done without using curvature. In fact, this is how really good professional surveyors, these formulas are all built in, and it has nothing to do with the curvature of the earth. It has to do with what they can't see because of distance and mirroring and things like that. Now combine that mathematics that's going to be in a spreadsheet just as easy as the earth curve calculators. Combine that with, let's say, the P1200, P1400, whatever, this new technology that's coming out that's going to let us see, and with combining it with like ultraviolet filters. I'm sorry, infrared. I keep going to ultraviolet. Infrared filters. We're going to see distances that are amazing, 400, 500, 700 miles in some cases. And it's all going to be because of technology, and the mathematics is going to tell us exactly how much is hidden at the bottom, and we'll be able to match it up. If we see, we saw the last time on Sun and Moon, I saw that video of across the lake where we saw the tower in Toronto. And to me, that looked like you could see almost the base, the steps walking up to it. But let's just say that the bottom 7 feet was cut off, and you could tell that by looking through the photograph. Well, this mathematics will tell you that. You plug in the numbers, will say, oh, 7 feet should be hidden. And then you'll see that it matches. And if it matches, it's not a globe, because that's based on flat. It wasn't intentionally based on flat, but no curvature was ever plugged into that. So if I can, let me just continue with this and get rid of this. And then I'd like to ask for volunteers maybe. So going back to the spreadsheet, it's obviously there's some other factors involved. If you have a phone, there's a free app that gives you the barometric pressure. Now, there's a thing called a sling psychrometer. And what that is in fact, I'm going to look it up and get you guys to see it, because this is where I need the volunteers to I'm going to show you how easy this is going to be. Here we go. These are called sling psychrometers. Now, these are like $100, $45, but you can actually get them for under $10. And let me just show you one if I can get a bigger picture, because this is what a volunteer would have to do. Now, this is a fancy name for being able to figure out two different temperatures, what's called a wet bulb and a dry bulb temperature. Let me blow this image up. People can see it. It'll probably blur out, but that's okay. Sorry about that.
That's okay, Rich. Looks good. Oh, it's just gone.
Yeah, I want to redo it again because some of it was cut off. Alrighty. I know it's blurry, but imagine you hold this part in your hand and you just sling this around. You just rotate your wrist like you would, I don't know. There's a little toy you can do that. You just rotate your wrist and this will swing around in the air really fast. Now, this has two thermometers on it. This one right here is called the dry bulb thermometer. This is just a regular thermometer. Then you have what's called a wet bulb thermometer, and it's the exact same thing except it's got a little sock on it, a little cloth that's put on it, and you wet this cloth with water, and then you sling it around for like 30 seconds to a minute. There are electronic ones that'll just blow air on it. We actually used an electronic one when I was in the Navy. When we did our observations, we would turn on this fan and it would blow on these two. And what happens is because evaporation causes cooling, the wet bulb temperature will be lower than the dry bulb temperature. The only time that there's an exception to that is if you have 100% humidity, then both the wet and the dry bulb will have the same figure. But you sling this around for a certain period of time. You read both the wet bulb and the dry bulb temperatures, you note them, and then you put it with the barometric pressure, and then you will know exactly what your air density is. It's that simple. So, with that in mind, let me pull up Snell's law now, if I can. This is pretty cool, huh? Today you can just pull up anything. And this looks like a good one here. You know, it's like my internet doesn't work as good when we're connected. I think you're right, Astral. Maybe they don't want us to work right.
Yeah, it's there.
So you got all these different things here with science about Snell's law. And of course, I can't get an image that I want, which all of science agrees with. And yet, if you apply it to the flat Earth, and all of a sudden it doesn't apply anymore. It's so amazing. So again, I'm explaining a lot of this because the volunteers need to know what they're getting into. So the volunteer would have to take this scale, which is, I don't know, 6 inches by 8 inches, and the weight, which is just a little, I don't know, 2 inch by 2 inch, 500 gram weight. And they would have to perform this experiment. If they're indoors, they would still use a sling psychrometer. They would still use the barometric pressure app and just record the figures. But here's Snell's law. And here we have an object being stuck into water here in this case. And the water, because it's more dense, bends it down. It's that simple. Now, if we were going from water to air, it would bend it up. So this is what everybody wants to use for standard refraction. Here's the problem. With observation, we're not changing from air to air. We're not changing from air to water. We're going from air to air. There is no change in medium. So what they've come up with is some sort of fancy thing saying, oh, well, the density, it's always more dense or less dense, whatever fits their bill, looking into the distance. Well, if you do, now let's look at it this way, an observer on the left side here, an observer on the right side, and we're looking across a lake, and you're going from air to air. I'm sorry, there's no other way about it. The other factor is what's called the angle of incidence. Imagine this is a spoon stuck in here and it bends down. If you stuck the spoon in straight up and down, and I demonstrated this in a video, there is no bending because your angle of incidence is 0. So those two factors are required. Now, let's say this was isopropyl alcohol, and I think that isopropyl alcohol is more dense, or just pick some liquid that's more dense than water, but you can still see through. The object would bend even more because you have a difference in the density. Now, there is a calculator which allows you to find out, let me go back here, exactly how much bend you should have. So let me put in here, here it is right here, calculator. See what we got here. See, you have a refractive index. Air happens to be 1.000. Refractive index 2 is you're going from air to air when we do these flat Earth observations, correct? So you're going from 1 to 1. Angle of incidence doesn't matter if it's even 40, let's say 43 degrees, which is you're never looking at 43 degrees. Oh, here we go. Oh, what's it asking for? Oh, I lost it. It actually was asking for barometric pressure, I think. Oh, where was it? Let me go back.
That looks complicated.
It really isn't. Well, if you're going from 1 to 1.3 or 1.3, which I think is what water is or something like that, angle of incidence is, let's say, 5 degrees. See this angle of refraction you get? 3.8 degrees. That's how much bend you would have, 3.8 degrees. So if you went from air to water, I think water was 1.3.
Sorry, Rich, to interrupt. How can you find out what refractive index is of? Yeah, there you've got like 1 and 2. How can you find out what that is?
Yeah, I'll show you.
Where do you find that?
There's a chart. Oh, brother. It's actually pretty cool. Here we go. Let's pick this one.
Can I ask how? Yeah, all right. This might sound ridiculous now. How trustworthy is this that we're seeing? Is it standard, or is it? I mean, is this what everyone goes off?
This is what science.
Is it true?
This is what science goes off. So, if you use their own science against them,
yeah,
is really what it is. It's like Dave Marsh with the what is it? The second law of planetary motion by who is it?
Kepler.
Kepler, thank you.
I was going to say that, but I just thought maybe that's right. Yeah, carry on.
Actually, everyone I pick here isn't giving me anything. Isn't that interesting? Oh, what the heck? Let's try this again. Refractive index of crop juices? That's unbelievable. Well, what they've done is they have tested these different things. They have tested like going from air to water and water to alcohol. There's a very nice chart that I had before. I'm trying to find it. It gives you exactly, here's one here. This is giving you some ranges. This is looking through different stones like diamonds and things like that. It gives you the RI is the refractive index. So they've gotten specific numbers for every different thing there is on the earth that they can think of to do. I don't know why I'm getting French categories there. Interesting.
I thought it said French fries. What?
Yeah, I don't know what's the refractive index of French fries. But see, they use these these specific scientific apparatus to figure out what the refractive index is of all these different things.
A refractometer measures the angle at which light refract or bend as they move through a gemstone. The measurement, RI.
What's that noise, Astral?
Oh, it's my kettle. Sorry, guys.
Oh, that's pretty cool. I like that.
I'm just making a cup of tea.
So I'll just I'm just bringing this picture up to bring a point up. It's just amazing what I can't find when I'm live. That I can find seems like immediately when I'm not.
Always the way, Rich.
Yes. So let's take a look at this glass of water. And I got to address this too, because I swear, Karen, the idiots abound. When I did this to show that it bends down, they don't realize that they're arguing against their own science. But they were like, "No, you're looking through a glass, and glass has its own reflective index too." Yes, but that's a variable that's applied to both the top of the glass and the bottom, where the spoon is in air and when it's in water. So if it's applied to both, then you get no additive or variation in the experience that you're going to have. It's just idiotic stuff that you have to deal with. But they will use anything to cognitive distance themselves away from the truth. So in this case, if I was to put the spoon in, top to bottom, and trust me, you can find these. You can find these online where you can verify this for yourself, but I'm not going to have everybody wait on me. But if you take a line, if you put the spoon in like this, straight up and down, that's how it will look. It will not bend at all because your angle of incidence is 0. I even had somebody argue that. No, it's 90 degrees. But if you put in the sign of 90 degrees, that equals 1, and it's the same thing as 0. So if you're looking straight up and down into the glass or you're looking perpendicular 90 degrees, you're going to get 0 bend. And this goes along with Snell's law. But if you take the spoon and you start to rotate it over like this, let's say that's a, I don't know, 40-degree angle, then you get this type of deal. Air to water at 40 degrees, you get this much bend. And they've measured these things precisely, just like with through a diamond or whatever. So if you are looking over a lake, and we all know that the horizon rises to eye level, correct? So unless you're looking way up at a tower or way down at the ground, your angle of incidence is pretty much 0. So no matter what the refractive change is in the density of air, like let's say it's more dense over here than here, which the refractive index, the difference would be like 1.0 on one side and 1.000002, let's say on the other side. So minuscule, it doesn't make any difference. So I argue the angular difference of the angle that you're looking through is, as long as you're looking at the horizon, going from eye level to eye level, horizon to horizon, so to speak, you have 0 angle of incidence. Now, just to illustrate that point again, let's say we didn't have water here. We had, or let's just fill the glass all the way up with water and we stick the spoon in, same angle. Would we see it bend? No, we wouldn't, because you're not changing from one density to another. It's all the same density, water. Or if it was all air, you stuck the spoon in, no matter what angle, it isn't going to bend because you haven't changed mediums. Because you don't change mediums when you're looking at an object 30 miles away on the horizon, there isn't going to be, if your angle of incidence is 0, I don't care how much more or less dense it is in the distance, it can't bend, according to Snell's law. And Snell's law is one of those laws I think is actually true because they can actually demonstrate it over and over and over again and get the same results. Whereas the second law of planetary motion fails with the moon. So, and then when Dave Marsh said that Kepler came up with that second law looking at Mars only, and before they even had telescopes. So how in the hell did he come up with that? And they say that's true. Well, the moon busts that. I didn't do a good job in my video to show it, but I will in the future. You can guarantee it. So the bottom line is, especially to you, Astral, is we're gonna know what the density is at point A and point B. Let me open this up since this has been the discussion lately. If I can find it, this will do. If we're looking across this lake, here to here, and we're looking at eye level, there's no angle of incidence. But what we can do is we can have a person over here at the same time I'm filming over here, and we can take our barometric pressure and our sling psychrometer readings, and especially if we can get a boat or even just hang over the side here and use a sling psychrometer at the same time, we can get the barometric pressure, the wet and dry bulb at 3 different locations, which will give us the air density where we're shooting from, where we're shooting through, and where our destination is. We can plug all that in and say, okay, with all this, we should have at most a rising of 3 inches or 3 feet or whatever it is of the object in question. We can plug these numbers in, and using these numbers that I just saw people are now coming up with to be able to tell what I was explaining before, how we can tell exactly how much would be hitting by the mirroring effect of the water. Oh, and by the way, I saw another picture of this, and I haven't commented on this. Other people are saying, yeah, the cars are going up 90 degrees and coming back down almost, because it does look scary as hell. But the picture I saw, these weren't nearly as severe as this, which would be another indication of distortion. But that's the long and short of, we're going to be able to very soon, with the correct equipment and the correct mathematics, be able to plug these in and say, okay, see what you're looking at here in the distance? You see this water tower back here? That should actually be 2 feet lower because of refraction, or 2 feet higher, or 1 feet. And I think in a lot of cases, it's going to be even less than a foot. So we're going to be able to mathematically and scientifically, with their own stuff, with their own formulas, with their own things that they've come up with, show that this standard refraction BS is just that, BS. It's just bunk. So to me, it's exciting times coming with photography with flat Earth, really is, because it's going to get to the point where even a lot of the cognitive dissonance people are going to say, whoa, I got to step back from this, because they're showing things that are clearly impossible.
People understand what the curve thing is. Even when you tell them from here to here, there would be a missing curve bit that's not there. You know, we don't see the missing bit. We don't see it as missing. You know, they don't understand that bit of the curve bit that you would, you know, like in the future day, in that picture, in the fall, you wouldn't see it like that, would you? You wouldn't see the land the other side like that.
No. And here's another thing I want to show too, since we're talking about this. In fact, I'll pull up the one that's the meta crap one. So let's just take that example, that lake, 24 miles across. His viewer height was 150 feet, but I'm going to do like let's say a 10-foot observation, just to give you, okay. The drop is 384.1 feet. So that water tower in the background should be 384.1 feet dropped if you're 10 feet above the horizon, above the surface when you're doing the calculation. And by the way, what's nice about that lake is the shoreline on both sides is 12 feet above sea level, roughly, give or take a foot. And so is the water. It listed all the way across as 12 feet above sea level. So we definitely have flat all the way across, and even on shore. You can go a quarter mile inland and still have 12 to 15 foot above sea level. So it's very, very, very flat there. But here's what people are not understanding. Oh, now before I get there, the standard refraction is just total BS. First of all, he's got R in here, the radius of the Earth, which cannot be proven. And when you understand how they come up with that, it's a circular argument. What they use is oh, well, we know that the sun is 93 million miles away. And if you have an observer in England, look at the position of the sun, and you have a person in North Africa look at it at the same time, and you look at the arc of the distance from one edge of the sun to the other, you can calculate the radius of the Earth by that. And then you're like, okay, you started with, we know the sun is 93 million miles away. How do you know that? Well, guess how they do that? they do that in a circular argument. They just say, oh, well, we got the distance. It's hard for me to explain. They use one to explain the other. The radius of the Earth. Oh, they take the radius of the Earth, and then they project that out with the arc of the sun to get the distance, 93 million miles. But then they do the revert. They use this. I have to look it up to get you the exact numbers, but it's a circular argument. It's like I can't think of a good example, but trust me, you cannot come up. There's no proof of the radius of the Earth. There isn't any. But let's just assume they're right for whatever reason. They take standard refraction. In this case, they're saying the refracted dip. Remember I told you it's going from one medium to another, what those figures are, and how much, at what angle are you looking at it? Here we have 0.052 degrees. Now, it doesn't sound like much, but it changes the hidden amount from 270 feet to 224 feet. So suddenly, magically, about 55 extra feet shows up just by using this calculator here. And no matter what the conditions are, isn't this amazing? No matter what the conditions are, this is what the globe earthers will say is the amount of refraction. They use this fixed formula. But if we take video across the lake, no, it's more dense. It was humid. It was less humid. You got all these things where they come here and they have this fixed thing. Well, like I said, we're going to use sling psychrometers and barometric pressure readings, and we're going to have exactly what it is. None of this guesswork. And guess what? It's going to blow this out of the water because it's just BS. Boy, I got close to cursing. All right, now going back to this supposed bulge over here, and boy, they argue, no, it's not a bulge. It's not a bulge. It's just following the curvature of the Earth. All right, fine. Let's take that. Now, this is wrong, actually. And I didn't even realize until I really thought about that picture, that lake. Really, you're always at the top, correct? No matter where you're on a ball, you're always at the top. Well, maybe it is right. I don't know. But see how here's where Soundly was. And the Earth just drops away from him, correct? Which is correct. It has to drop away from you no matter where you are. But in the picture, it goes up and then drops. So it's like he's not standing on the highest point. He's standing on one of the lowest points. It has him standing here, looking up at this, and then it curves back down. If that makes sense. However, here's the point I wanted to cover here. Now imagine, I wonder if this will let you move this. It does. You're at the center here, and you're looking across the lake. And they're saying the water's just following the curvature of the Earth. It's not a bulge. Okay. How does water, and they'll say, I'm going to have to do this. I'm going to have to screen capture this, show it. It's just to show the idiocy. I just can't believe people argue this. It blows me away. So they'll say, you have water here. All right, just imagine this is the top of the lake here and it's curving. They're saying gravity always pulls straight down at wherever you are. But what they don't realize is perpendicular to the Earth, which is what they're saying, is like this. It's not like this is actually perpendicular to the Earth. If that makes any sense. Now, why am I doing that? Because if gravity always points towards the center of the Earth, which is, this would be the line right here, the water, I mean, obviously water doesn't have a brain, but let's just say it does. Water would know it's not level here. There's a downhill here. This is downhill. There's no two ways about it. So the water has to flow down until it becomes perpendicular, which is flat.
And also, Rich, I remember you talking before about sea levels. You know, like when you're flying across and then all these different people don't understand how different everything would be if we were living on something like that.
Absolutely. That's a good point. Let me show that, because that's
Also, you know, when you were talking about this angle of the sun, the refraction, where it was they were taking, it had 92.000. Maybe that's it. The sun is 9.2 miles away. Maybe that's what that means.
Maybe. It could be well, you know what I believe about the sun and the moon. They're both images that we don't see the actual thing. We see an image of each one. All right. So people need to understand the importance of this right here. Oh, by the way, I've gone through this twice, the Suez Canal, and there is absolutely
Hang on
no
a second,
difference.
Richard. Rich, what
Yes,
you're
sir.
showing us there, man? I don't understand that. What is that? The green, the blue, the brown. What is it you're showing us? Libya, Algeria.
Oh, this is Google Earth, whatever they pop on there.
No, it's because it's flipping round. That's why I didn't understand what it was.
Gotcha. Anyway, I mean, you have the Indian Ocean here, you have the Red Sea in the middle, and you have the Mediterranean, and the water is almost non-flowing. I mean, it flows, but it's nothing. So you would have to have a massive difference in sea level here than you do here because it's a globe. It's just the way it is. Now, when aircraft are flying, especially on an aircraft carrier, it's very, very, very important that they know exactly what the barometric pressure is for their altimeter. It's not their altimeter. What's the device that keeps track of their altitude? What do they call it? Anyway, let's say they take off from the ship, and when they come back, it's foggy conditions, and they can't see the carrier until they're really right up on it. And it's not like being in the United States or the UK or someplace in Europe where you can divert to another airport if visibility is too low. I'm sorry, that's not the case. When you're out at sea, you take off from a carrier, and if you're in the middle of the ocean here, you have to land back on that carrier because you don't have, first of all, you don't have enough fuel to make it all these places, and you wouldn't want to have that anyway. So the deck of the flight deck, if I remember correctly, was 96 feet above sea level. And when the aircraft takes off, it might be 4 or 5 hours before it comes back. And the Hummers, the ones that have radar on them and things like that, they could be out 6, 7, 8, 9, 10 hours before they come back. They just go forever. The reconnaissance aircraft. So let's take that for example. If let's say the ship is going 25 knots and the Hummer's been out 10 hours, that's 250 miles difference where the ship is located than when that Hummer took off in the morning. So when it comes back, let's just say it's low visibility and they can't see the aircraft carrier until they're right up on it. Well, the reason why they are not afraid to crash into the ocean or the aircraft carrier is we would transmit to them our current barometric pressure, which is calibrated to sea level. And then they know, okay, I can't go below 96 feet or I'm going to crash into the back of the moving aircraft carrier. So again, they calibrated before they took off what sea level was, sea level barometric pressure, 250 miles away. Now, if you go back to the calculator, and we're not talking about an observation here. I can get back to the top. Oh, there we go. 250 miles. And let's do the calculation for that. All right. You have a 7.9 miles difference in sea level at 250 miles. Think about that. So basically 8 miles difference in sea level has to be 250 miles away. So if sea level was different at all different places around the world instead of standard, whatever it is, the Hummer would be 7.9 miles too high or too low when it's trying to land on the aircraft carrier if it doesn't have any visual, if that makes sense. There is no, for example, sea level here is the same as sea level here, is the same as sea level here, is the same as sea level all the way over here. They're exactly the same. And if it was different, and this is what most pilots have to start thinking about. They would have to have an onboard calculator that would calculate exactly how much different sea level is at their area versus where they took off. Let's say they took off out here in San Diego and landed in Baltimore. I mean, that's 3,000 miles difference. The difference in sea level's got to be, well, let's find out what it is. Or let's say,
If we were this spinning thing, I really don't think I'd want to go in an aeroplane.
well, think about it. Why would you want to go in an airplane if they had to calculate for different sea levels, no matter where they were? I mean, the calculations, Karen, would be so immense. I don't even know if a computer on board could even handle
Like
it
a
with
horrible
today's
roller
technology.
coaster ride, wouldn't it? You wouldn't want to be on.
Yeah, and you'd be scared to death to land without any kind of visual confirmation because you could never tell really how high above sea level you are. If an airport is 300 feet above sea level, what sea level? Think about that. What sea level are you basing that on? Oh, local sea level? No, it's based on sea level.
But again,
Period.
Rick, you were talking about this, and I thought, oh yeah, a few weeks ago or a month or two ago, whenever you mentioned it, so I mentioned it today. But I was thinking, oh yeah, I hadn't thought about that. Do you see what I mean? So I hadn't thought about that one.
Yeah, well, it's even barometric pressure that's taken in all the different weather stations all over the world. Most people probably don't know it, but that barometric pressure is reduced to sea level. It's not the actual number they're getting. Let's say they get 1,015 millibars at Chicago, and they will take that and say the barometric pressure is 996 millibars. And if you're not informed, you're like, wait a minute, I just saw the barometric pressure on the barometer and it said 1,015. Why is he saying 996? It's because they take that number and reduce it to sea level. And there is no different number to reduce it by other than your altitude all over the world. So when you have pictures of what are called isobars, this right here, where these lines that are all connecting, you get a better picture here. There we go. People have seen stuff like this. All these lines right here, they're connecting equal lines of barometric pressure. And guess what? It's all based on reducing it to sea level. So a person out here taking a barometric pressure reading, let's say I'm on my ship down here, I reduce it to local sea level, 96. Actually, we were about 110 feet above sea level in the weather office. So we had a little calculator reduce it by 110 feet, and it makes your barometric pressure actually higher, not lower. But there's no, okay, oh, my sea level at this level is really, I got to multiply it by 0.842 because the sea level is so much different than it is up here. No, they're all standard. There's no different formulas. And it's right in front of our face. It was in front of my face the whole time. Never thought about it. But on the globe, it's absolutely necessary that sea level is different at different locations. Just is. There's no way around that I can see. So anyway,
Rich, can I just say in the question room, in the chat room, Lee is saying, Rich, I have a survey I've been meaning to do, the tidal differences between high and low tides at the equator and further north or south.
Can you say that one more time?
Leah in the chat room just said that they wanted to do a survey where the tidal wave differences between high and low tides at the equator and further north or south. He wants to do a survey of their own.
Okay. Is that a question?
They said Rich. They want to do the survey as well. Because the only way you prove it is a bit like, even though that footage from Skyfly wasn't real, but putting what they're showing happens to the moon on the equator and then what's happening in the north, many of us haven't even put these bits together to see the differences of what they're really showing was going on.
Yeah. What was her name, Leah?
Leah.
Okay, let me explain something, Leah, to give you a little tip on something, and you can go from there. What science says, and I noticed this when I was a kid, and I did question that something was wrong. Science says that when the moon is closest to you, that's when you'll have a high tide. And when it is opposite of you or the furthest away also, you'll have a high tide. What they say is the gravitational pull pulls on this side. I don't know if you've ever seen the diagrams. It's so stupid. But they actually show how on the other side you would have a high tide at the same time. So let's just say the opposite part of the earth there is here somewhere. So they should experience a high tide at the same time. Well, I used to do a lot of crabbing in the Chesapeake Bay when I was young, when I was a teenager. That's here. We'd come down here and go out in boats. And I noticed something. Plus, I was also in the weather, so I knew what the tides were and different things like that. That when the moon was closest to the east coast of the United States, it was not high tide. In fact, it was much closer to low tide. However, if you go over to, if I remember right, now you got to check it. I'm going to be doing this soon again anyway, rechecking this. You go over to like off the coast of Portugal and Spain, when the moon is closest to there, they're having a high tide. But pick another place. Let's just say Turkey. And again, these might not be the exact locations or whatever. They have a high tide when the moon is not closest, not furthest away, but like in between. And it happens over and over and over again. So what they say is, as far as gravitational pull, that's absolutely can be disproven immediately. Because if that was the case, and trust me, I know all the arguments that the trolls have for this. Oh, well, the different inlets have different times where the water has high tides. Generally speaking, they're all very close, within an hour of one another. And it's when the moon is furthest away, or not furthest away, what is it? Oh, no, when the moon is closest on the East Coast, you have a low tide. It's just the way it is, give or take an hour.
Yeah, and sometimes there's well, every time that the moon disappears for a few days, we still get tides.
Well, let me give you the conclusion I've come to so far with the moon and tides. There is no gravitational correlation whatsoever, none. However, there is a positional correlation. Most people don't understand how tides work too. Water accumulates. That's how you get more water in one place than another. Just like snow accumulates. That's how water, it's not pulled. It's actually pushed more is a better example. Many people have been in a bathtub and you slide back and forth and you create waves. That's you causing water to accumulate into a certain area and then it dissipates, which is why it would never follow the curvature of the earth either, because it can't do that. It's got to dissipate and it's got to get to its own level. Let me show you what I mean by that correlation. All right, many have seen this picture right here. See how they have the moon and the sun here, and I guess they have moved this way. I'm not sure, or I guess they're moving around. Imagine the moon is inside the waters above the earth. Let's just say that's this right here. I'm not trying to put the moon in the wrong place. I'm just trying to use something for graphic illustration. Imagine these are the waters here. And there's also waters under the waters. We know this. It's not very well known, but science has revealed those who have gone down to the bottom of the sea in the Atlantic and the Pacific in these special vehicles. They say it's like glass. There's like a glass barrier between the ocean floor and what they can see is more water underneath that, a different water system. So there are waters underneath the waters also. But imagine this is all one big enclosed fishbowl, and here's waters under us, waters above us. Now, if you have a moon and you push the moon through it, it's going to have an effect on the whole thing. It's going to cause water to push and accumulate in certain areas. And because of that, as you know, if you push water up in one area and it's an enclosed system like this is, it's got to draw the water from somewhere else. That would make sense versus gravitational pull. Plus, this also makes sense where the oceans have tides, but lakes do not. And please don't tell me it's the dumbest thing I've ever heard of. No, no, the Great Lakes have a 2 millimeter difference in high and low tide. Are you serious? I mean, can't you tell when someone's BSing you? 2 millimeters? Anyway, Lake Superior is extremely large, and they're saying it has a 2 millimeter difference between high and low tide. I'm sorry, there is no difference between high and low. There is no tides because they're not connected into this closed off in the system here. But if you have land and then you have a lake in the middle of that, like Lake Superior, Lake Michigan, Lake Pontchartrain, they are not going to have water pushed or accumulate because the moon is pushing through the system. That's my theory anyway. So let me finish with this, and then I'll finish, and we can hopefully go to questions if anybody's got any. What I'd like to have is, I talked to somebody in Washington, and in fact, I might fly up to Washington to meet this person. The Puget Sound is one of the great places to, I think, do flat Earth observations and proofs. Probably better than Lake Pontchartrain. Oh, and speaking of that, I was going to go around January 20th weekend. It's MLK weekend. I could bring my son then to help me because he's in college and he has off that Monday, so we could go to a 3-day weekend. And I wrote Soundly and on Twitter, and he said, well, it's probably still cold enough then. To me, it doesn't. I think he's saying cold for visibility. I don't know. But to me, you don't have to have cold. I've called 30-mile visibility on nice, sharp, crisp days when it wasn't cold. And I've called 0 visibility when it was. So, yeah, I mean, yeah, it tends to be a little bit better with less humidity and stuff like that. But that would have been a perfect weekend. Then I suggested I was going to go in April because when I looked at the climatological data, they get a lot of rainfall. And I talked to my buddy who lives in Mobile, Alabama. I've hunted with him before in April. It's a fantastic month. And I told him, I said, well, maybe I'm coming down in January. He goes, why are you coming down then? It's cold and rainy all the time. So that's when I looked at the climatological data, and sure enough. Well, then Soundly sent me climatological data to show that there isn't much difference in the rainfall between January and April. So I should come in January, or yeah, April. But there is a difference. I mean, there was 4.7 inches, I think, in January and 4.3 in April. Yeah, that doesn't sound like a lot of difference. But what happens is in January, most of the rain comes from stalled out fronts or low pressure systems in the Gulf. This is where you'll get 2, 3, 4, 5 days of just dreary gray. Never happens in the UK. I'm just trying to explain it to you.
Can I ask you something? I don't want to be horrible, and I'm not attacking Soundly in that, but I was watching this. It wasn't a very nice video. It's about horrible things, you know, someone murdered, whatever. But they were saying that this person had showed all these pictures of themselves everywhere. But on looking at them, they were all photoshopped. So he put them together or put his head on the top. So is there any way you could verify that picture?
Well, it's actually a live video. It's not really a picture. You're talking about the one on the bridge that's distorted on the left? Yeah, he's actually shooting a video. So there's thousands and thousands of pictures. Right. Again, I think I know how it's done and how the distortion is done. But I'm going to keep that to myself for now. And to me,
I haven't really seen it as a picture. You know, like I've seen so many posts about it.
Yeah, it is. It's actually a video. And but here's the deal. In April, like I said, in January, you get a lot of rainfall. They're almost the same rainfall, a little bit more in January. But the difference is it comes from low pressure systems for the most part and stalled out fronts in January. So you run a big chance of having many days in a row with poor visibility. I can't take that chance because I can't stay that long. In April, it's usually showers and thunderstorms that happen in the evening. That I can live with. In fact, if we had showers and thunderstorms, chances are the next morning would be fantastic visibility. So that's the difference. So it's not just saying whatever. And here's the deal too. If because then he said he was coming January 1st or 2nd and 3rd, which doesn't help at all because that's the worst time to travel because of the New Year's holiday, as far as that time period. So that's fine. And you know what? He doesn't have to meet me there. It's up to him. I'll let him know in advance when I'm going to be there. He doesn't want to be there. It's up to him. I'm going to show up with equipment and I'm going to do some flat earth experiments. And what it is what it is. I know water can't hold that position without flowing towards level. It just cannot. People can say, you know, gravity pulls towards the center of the earth, so it ain't going to move. Fine, but it's not. I mean, if you argue that, it's perpendicular. And if you have a bulge in the earth, it's not perpendicular. Plus, how can you show that it's following the curve bulged up there? Let's go back to the picture one more time.
If it does all that for the ocean, how could a butterfly fly?
I'm not following you there.
Well, if everything is, if water's kept bendy, how can, you know, like with this gravity and all this kind of stuff, then how can a butterfly fly? You
I don't
crush
know.
it. Whoosh.
There we go.
No bendy water.
How can water stay here or here? See how it's curving up? They're saying that's the curvature there. Fine. But if they're saying that gravity pulls directly towards the center of the earth, and that is the theory, then if you draw a line there, let me pick the color we can see here.
In case anybody hasn't seen it, Rich, how far is that line there that we're watching on the bridge or road? How many miles? How far is that supposed to be?
Well, the widest part of the lake is about 24 miles.
This
Now,
is, can I just, this is Lake Pontchartrain, isn't it?
Yes.
Right. That picture there, Rich, anybody who looks at that, seriously, anybody who looks at that, that is bollocks, because you're not going to see that in real life like we're seeing it there. That is just, I mean, forgive my French, it's total and utter bollocks. You're not going to see a curve like that on any kind of water, because it just doesn't do that. Unless you're at a higher level and you've got some sort of a slope that's going down to a lower level where the water will be collected. And it isn't, is it?
That's correct. Water cannot do this. And that's what I'm saying. If he doesn't want to show up, he doesn't have to show up. If I show up with a P1000, shoot across this area and it's flat, well, that's all I need to see. Here you go, Karen. Now this is sped up, but you can see it's many pictures. But look at these. Look at these. This is now. Wait till you see another picture of this lake. See if I can get there. Here it is from the side. They're not quite so steep, are they? Here's another Soundly photo, I think. See how steep and distorted it is?
Look at those bridges. I wouldn't want to go on that.
Oh, I couldn't do it. I have a phobia that this would trigger. So I couldn't do it. But I don't think that's the way it is. I'm trying to find the picture. Yeah, see, here's the same thing. Even this. Oh, okay, here you go. These right here, Astral, these are seventh, and these are the first two, which are 6,000. These are 7,000 feet apart. So between here,
7,000 feet apart.
absolutely, no doubt about it.
Seriously?
So you have 1, 2, 3 just to the top here. So you have 7, 14, 21,000 feet. So this is 4 miles. So that's the problem. It's so compressed in. And you can see the water's rising. There's no way that can happen. And people want to say, hey, nobody's saying it's a bulge. It is a bulge. What the hell else is it? You can already see out here where it's starting to go down. So you have the water flowing left to right, but it's not flowing down.
It's not
And that-
bulging. There's absolutely no way, because
No.
we know water will not bulge like that. I mean, we're looking at the bridge there. We can see the construction of that bridge. That's just distorted there to the left. Everything you see there to the left, that's distorted. Mainly, I would say, from where the height is. You look at where they're going over that big, whatever it is. I mean,
Yeah, can you
for
imagine?
God's sake, man. Look how high that is. Yeah, sorry, Karen.
The bit in the background, you know, the higher land isn't distorted, is it?
And look at the right side. It's totally flat.
Yeah, the land behind isn't all distorted like that.
You know, I don't. Seriously, I don't care for that photograph, that film, that clip. I've seen it 1,000 times, and it's junk, because we know water cannot form to that shape.
I'm
It
fine,
can't. Not when it's laying flat anyway, and it's a lake, isn't it?
That bridge, they frighten me. I'm sorry, I don't like the look of them at all.
Yeah, there's no way I could do it. Absolutely
Well,
no way.
if you actually just look at the cars coming over that hump on that bridge, that just doesn't look normal.
No.
I mean, does it?
Uh,
Why would you build it like that?
They'd
I
have
mean,
to
it's
call.
short and steep, and it's
They'd
like.
have to call. Yeah, they'd have to call an ambulance for me, because I'd be
What?
freaking out.
What is that there for? Like that there? What is the reason they have to go up and down on that bit
Well,
there?
so big. It's so big, ships can sail under it, Karen. I would surmise.
Yes.
Well, I wouldn't want to go on it.
Yeah. I'm trying to find the picture that somebody took that is absolutely different. I mean, it's the same bridge, and you don't have that distortion at all.
How about some pictures showing the construction of that bridge?
Oh, that would be interesting. But yeah, I could never go over that bridge, Karen, if it was like that. And here's the same thing, and I'm going to observe this too. And this is what the lady pointed out. Let me get this right here. These power lines. You've probably seen that too. See if I can find out where it shows. He's got that all distorted. She told me that if you take something we're used to seeing, like that bridge, and we know how that usually should look, it should look flat. In fact, forget about this. Let's go to, wait a minute. Let me see. Maybe it's here. Yeah, see this right here? Interesting. The heck? Even this right here, she said, we know what this normally looks like. So if you shoot it on an angle like he has, and you can compress the field of view, that's when you get these, that's when you can create these things. Now, that's not specifically what I've come to learn, I think, is causing this. And I don't want to say what it is until I can verify it. But I'm definitely not going to, what's the word? I'm not going to
go out.
I'm not going to release.
Limb.
I'm not going to release everything I know.
Can I just say something as well? Go back to the photo there with the where it's curving the bridge at the end. Oh, that, yeah, whatever. Or the other one. Yeah, that. Now, how could that be bending over the edge there? And what I'm thinking is, if the bridge there or those pylons are slightly veering to the right, as we're looking at them now, for where that orange red light is or whatever, you know, a little bit before that, 5 mil before that, if it starts to veer a little bit to the right, surely that will give that effect that it's dipping down like it is. Do you understand what I'm saying? Like a perspective view.
Yes.
If you take something like looking at that now, exactly as it is, where that red light is at the end, that, yeah, you can see it, can't you? Imagine now that the brick or those pylons are slightly veering to the right. They don't have to veer much. I mean, 30 centimeters each pylon would give that effect, I'm sure. You know what I mean?
What he's saying is if they're not quite straight and they're slightly on a curve going on the land, then it'll
Well,
give
maybe,
that effect.
yeah, maybe the first 30, 40 pylons here are fine. They're all in line. But then the last, what we can't see, you know, the last light we can see there at the edge of where the water horizon is, that last lamp there that's lighting up, it's maybe they're starting to turn a little bit to the right there. And that's what's giving the effect that it's curving.
Yeah. Well,
You
I'm
know
going
what
to
I
try
mean?
to. Yeah, I'm going to try to find this on
We
the
can
fly.
play with that. We can do some drawings and shit and play with it. But I'm pretty sure that that's factual what I just said then.
Well, I'm pretty sure that is where I saw a video where somebody took Google Earth and from overhead and showed that, and it was perfectly in a straight line, no curvature. So let me launch this one more time and look at the lake. Well, you know, we've all seen the pictures of that that Chinese bridge that's 100 miles long that has absolutely no curvature for 100 miles, and yet over 25 miles, you know, it's like somebody else said, the only place the Earth curves is at Lake Pontchartrain when Soundly's there. I'm serious. Where else have you seen anything like that? We've never seen that in person. We've all, I guess you have these over there too, where you have these old binoculars or telescopic things where you put a quarter in over here and you look at over a lake or ocean or whatever. We don't ever see curvature or anything like that, ever.
No.
Probably spelling it wrong. Let's see if it'll give it to me.
To be a globe believer, it's actually so ridiculous, the whole thing, when you think about it. It's
Yes.
more ridiculous than being a flat plane and not moving.
Look at this picture from Lake Pontchartrain right on it. Does it look like it's curved? It doesn't go
No.
up and down. How did I do this before? I actually got, oh, you know what? I don't even think I had to do this. I think it's actually on Google Earth or on, there's actually some pretty decent photos.
It's crazy what we've been looking at and just not realizing, isn't it?
Well, look at this. Soundly's Lake Pontchartrain shows up in the main results. So how is that possible? Do you think they want to promote that for any reason? Think about
Because
that.
he's a flipping government troll, that's why. Disinformation agent. Gotta be. Why would you put some shit on there like that that's not factual, that's not, 100% verifiable?
Yeah.
Do you understand what I'm saying? It's like, that's
Oh, yeah.
ridiculous. Put Santa on there and say it's true. You know, he'll be coming soon.
Here's the same bridge. Same bridge. And this is a perfect perspective thing. Look how they look like they come
Look at
together.
that curve there, Richard. Oh my goodness. Woo.
Well, here's from the middle looking back. You can see it does this. Now, see this? This is one of those things that goes up to allow the ships to go under.
Yeah,
It doesn't
down
look
there.
it doesn't look anything like 90 degree or let's call it 80 degrees over the hump, does it?
It's not as violent as what was shown before.
Exactly.
How high is that actual section? It's there now. I can see it. It's not much. It's stepped over quite a few. There, yeah. Yeah, there. That's the height, isn't it?
Oh, that's
Really?
way different.
That's the height.
Oh my Lord.
Now, if you go back to the original picture that you showed before, it's almost like it's a flipping vertical.
Yep. So
It's
let me
been
go ahead.
compressed. The photo's been compressed. That has been compressed big time. Look. Are they the same? They should be.
Now, does that tell you you're seeing reality?
Come on, man. Yeah,
Come on.
seriously. Seriously. Wow.
And see this right here? That's all this. This is distorted too, if this is what this is. That, I mean, that wouldn't scare me in the least. This would.
Yes, I don't want to go on that bridge on the left.
I mean, come on, people. And here's the deal. These aren't even shot at too much of a different angle.
So how come the bridge on the left looks so different to the bridge on the right? Because don't forget, there are things with cell tower things in the background. They're not all distorted.
No, they're not. But to me, rearrange this. To me, all the distortion, or the vast majority of it, let's see.
Can I say something, Rich? The one on the left, I've got things sort of sticking in the water, but the one on the right doesn't. You know, those pylon-y things.
These
You
white
said-
things?
Yeah, they're not
Yeah,
on.
I'm
Yeah,
looking
but-
at that. It's not quite the same picture, is it, in a sense? But how is that then? Are we looking at it from a different view or a different place?
Yeah. I think we're this right here is from this side looking over, because these
How
these
far
are all
apart?
on this side.
do you say those
Because
things
there's
were?
one, I can see one right here, or looks like one. There's one right there.
Right. They look
These
so.
are they're 7,000 feet. They're over a mile apart, Karen.
Mm. So you might not capture it in that piece of. It might just be in and out of the picture.
To me, almost all the distortion is like right in here. Like
I think
this.
what I might do this weekend is look into this. I've seen it so many times before. You know, it's like, oh, it's incredible. It's still popping up, man. We're still
It's
talking
hard
18
to
now.
It's that many miles long that you're actually able to see any of the cars on the bridge. To be honest.
I mean, they should give air sick bags out to people getting ready to go over this thing.
Imagine you wouldn't want to put your foot down or something. Wait, you take off.
I couldn't do this. Seriously, I could not do it.
No, I wouldn't want to go on that
With
bridge.
With the phobia I have, I couldn't do this. I could do this.
We have a nice long bridge here in Denmark. It was actually one of the longest bridges in Europe. It goes from the mainland of Denmark to Fyn, another island, and then from Fyn over to Sjælland. And it's long, it's very long, and it's bloody high in the centre there, you know, and I've been in like a high-sided van crossing that bridge when it's been windy, and I've been shitting myself, forgive my French. I've been panicking anyway, because you can just feel the wind like blowing at you, and I'm looking at the windsock on top of the bridge there and thinking, please do not let me blow over the side, you know. And I don't think anyone has done, but I get so panicky every time I go. It's so high. It's so flipping high, honestly. Have a look into it. It's called Storebelts, bro.
You couldn't go on those bridges on a windy day.
You wouldn't want to, would you? But anyway,
It's like a great place to parachute from.
Look at this. I mean, it's just totally different. Oh, speaking of construction, looks like here it is. They were constructing this. Look at the horizon, flat and level. See, everybody is going to sound these photographs to prove the globe. And why? Because there are no others. Think about that.
Well, you know, it's simple enough to do. We can go into this Lake Pontchartrain bridge construction and find out exactly how they've done it. You know, we can find everything. I mean, the height of the bridge, how long between each, span and all that kind of stuff, and how much cement they used, how many men they used, how many people died, whatever. We can find out all this kind of stuff, you know, can't we, from the internet, you know, and then we'll find out. Height, how high was it? How level was it? Did they take into the Coriolis effect? You know?
Yeah. They only take Coriolis effect into account with a bullet. It's another thing. Stanley's the only person on the earth that's captured curvature, and bullet is the only thing that's really affected by Coriolis. Airplanes aren't, cannons aren't, baseballs being hit aren't, a thrown football isn't. kicked football over there, soccer ball, you know, they'd have to make all the fields face east-west, wouldn't they? Otherwise, they'd always be curving to the left or whatever when they kick towards the goal. It's just so many things are ridiculous that people buy into. One more subject, Karen, and then maybe we can take questions. Now, Karen, you know this. I became alarmed recently. I went to a library here, and it's a pretty big library. And first I was searching the Library of Congress online, which is supposed to have every publication or whatever that's anything, and could not find any encyclopedias there. And what I mean is, I'm not talking about Wikipedia and online Britannica or whatever. I'm talking about in print encyclopedias. So I went to my local library and I walked up to the desk and I said, I'd like to know where your reference materials are, specifically encyclopedias. And she said, we don't have any printed encyclopedias. I said, not even any old ones? She said, no, everything is online now. And she mentioned Wikipedia. So I was like, okay. So then I really started thinking about that. And I've been, one of my interests recently has been how they lie to us about history and alternative histories. And how easy is it now to change history when all you have to do is go in and edit it electronically? We have no paper backups to, say, hey, this is the way it happened, at least according to whoever. Not saying that the original publication was right, but evidently, and this came up in a Q post, it said, check how history has changed about World War II from a 1960 or 1950 encyclopedia versus 1970 versus 2000 versus now. And evidently, there's been a lot of changing of history. And you can even see this even in film. With World War II, any World War II films that came out pretty close to after the war, I'm saying within 15 years, they generally depicted the Nazis as evil, cruel, very intelligent, and pretty much just despicable people. After that, you started to have a phase into more of a joke. They were a joke. They were fumbling, bumbling idiots. Not necessarily cruel and mean, but just, and I'm not saying either story is right. I'm just giving you the difference that you can see in media. But the newer Hollywood and other type of presentations show Germany in World War II much different than the older ones do. And you can even see a transition period where they go in between. There was as a perfect example, there was most people, even in the UK, you probably remember the movie The Great Escape, because there was a lot of British actors in that. Donald Pleasance, and a few others. And Richard Attenborough. They depicted Germany as that was sort of an in-between type of thing. They were efficient, but they were goofy a little bit too. It was sort of the transition from very serious evil people to being a joke people. And I know it's not a movie, but we had a TV series called Hogan's Heroes, and the Germans were absolute buffoons. I mean, couldn't do anything right. Couldn't even assemble a radio hardly. And yet we grabbed all their scientists. So that's a change in history. It's a change in the perception of history. And I'm just using that as an example. And I know that's Hollywood. It's not in print, so to speak, but it's memorialized. But we have no memorialized history anymore if you take away our encyclopedias. And what I've done is I've ordered, and I was hoping to have it before today we went live. I ordered a World Book Encyclopedia from 1972, I think. See, in that particular case, I want to see how they portrayed, in particular, the distance to the moon. What I found was if you go back and look at the live broadcasts that have been recorded, ABC, CBS, NBC, of the moon landing, they were saying the moon was 221,000 miles away, unless they were just roughly saying, 250,000 miles away. But when they got specific, they even put it on the screen once. The moon is 221,000 miles away. And now remember, this is Apollo 11. Apollo 10 and 9 went to the moon, didn't land, but they went around it and came back. And yet they were off by, now they say the moon is 238,000 miles away. So they were almost 20,000 miles off in the distance of the moon. And think about how precise that trip would have had to be, and they were 20,000 miles off
Can
from what
I,
they say now. Yeah.
Rich, can I ask you, what is the distance? Because, well, I seem to hover between 248,000 and 238,000. I don't know. I'm just going off like, around about there.
That's about what they say.
But what is it officially? What is it? Do we know?
Officially they say it's 238,000.
38,000.
238,000 with some variance, as you say, apogee and perigee.
Yeah.
But they never had figures that high back on Apollo 11. After they supposedly went around the thing twice, they were still off by that much, according to now. And what happened was, my theory is, we're getting a lot of background. Astral.
Oh, it's me. Sorry, I'm moving my books around.
Oh, it's all right. What's happened in the meantime is something mathematically in their model had to be adjusted. That's my opinion. So they pushed it out to 238,000 miles. But what I wanted to do was I wanted to go back and look at encyclopedias in that period to see exactly what science said was the distance to the moon. And you can't tell me that something as precise as orbital mechanics being 10,000 miles off at least. That's from my house to the UK twice almost, or from the East Coast to it's 360. It's 3 trips, US to UK to back and back again. Is that right? Yeah, that'd be about 10,000 miles. So they were that far off and supposedly going at Mach 4 the whole time. I just don't buy it. I wanted to know when exactly did they change the number, and to me, it's another proof we didn't go. But they were actually putting that up on the screen. The moon is 221,000 miles away. Now, what I did was I went to time and date, went back to that date, July 20th, 16th, whatever it was, in 1969, and they've got the number at 238,000 or 9,000, whatever, it's supposed to be now. But how come NASA was saying it was 221,000 back then? And some idiot's going to say, well, you know that the orbits change over time. Yeah, the moon is supposed to be slowly getting closer to us, not farther away. So that's not an argument either. But that got me really thinking about how our education system has got us, we know, most people just want to absorb from authority. That's it. Don't test it. Don't try it. Don't find out if it holds water. Just believe it. And that is what our education system has evolved into. And the longer you stay in that education system, the more you're going to be of that opinion that what you've learned is correct. It shouldn't be questioned because it's been somehow questioned before and proven correctly. And just preach it to the choir or preach it to the rest of the slobs who didn't get that high of an education. And I came across Eric Dubay had a presentation. I don't know when, but somebody reposted it. And I'm going to be getting all that data down. And I may actually be doing a different channel with subjects like this, where we talk about, that. I want to talk about politics, things that are happening. But it's really dangerous what they've done and how they have systematically gone from before the 1850s in this country. Education has been totally flipped upside down since then to go along with government narrative. They've slowly but surely incorporated more and more of the population as far as age. They only went, I don't know, I think it was like what we today would call 4th graders to 8th graders. That was your education back then. And they've slowly expanded it to younger, now 4-year-olds go to kindergarten. And you even have preschool here where you send them in 3 years old to these and pay a lot of money for it. You can't even let kids be kids. You got to jam them into the indoctrination system as early as possible. Then they slowly expanded it the other way until they got up to 16, 17, 18-year-olds. And by the way, in the 1800s here, people who know Little House on the Prairie show, They depicted this pretty accurately. The older kids and the younger kids, they were all in one single classroom, one teacher, and that's how they learned, which is a much better system than what we have today, where they segment everybody up. It's so precise, the indoctrination that's going on today. That's why it's being done. But then, of course, they went beyond that with higher education. Now you have people in their late 20s who have been in school since they were 4 years old every year, still getting their degree in their late 20s, or their secondary degree, or their third degree. And they're so indoctrinated by the time they come out of that you can't even, and then these same people, and I've seen their comments and heard them, will say, why wasn't I taught Airy's failure or Michelson Morley in my physics class? I'm a physics major, for God's sake. Why wasn't I told about this? So some will wake up and present that, but it's like me in the Navy. All these different things, sea level, going in a straight line on a flat Earth type of map, no curve, no greater curve, seeing things on radar 60 miles away over ocean, which should be impossible. All these different things I never questioned because I had enough education not to question it, is really the truth. Think about it. If I didn't have enough education and I was a curious person, and I've always been a curious person, I would be asking. So that's the last part of, but I'm going to be getting into that kind of stuff because it really interests me. And there's an encyclopedia I can get of turn of the century, 1904 or 5. I'm going to get that. They've taken the hard books and they put it into paperback, and it's only like $30. I think you can get it at Walmart. So I'm going to order that too. But it's these different things I think that we need to preserve. If you got a printed encyclopedia, don't get rid of it, because it's so easy for them to revise history now with with this click of a button. Your history has changed, and you never know the difference because you can't go back and see that our earlier printed edition existed.
I've got a nice one here. This is, well, it's not that old actually. It's from 1975, but it's still good enough. It's actually very good actually. It's Reader's Digest. But it's a very good encyclopedia in that it's got, like, many different things. I spoke about this before. Dictionary. It's got the story of writing, the history of English, word origins, and better usage of words and things. Yeah, it's a good dictionary. It's got many things in it, so I like that. It's also got space travel and the history of space. It's got the history of satellites, the sizes of satellites, when they were put up. It's got everything to do with medical and medicine. So I love this book. I really love it, and like you say, Rich, the older the better, because they're probably less corrupted than what they are nowadays,
Do they give you a distance to the moon?
Yeah, it does actually. 238,900 miles.
Okay, so they somewhere between 1969 and 1975, they modified it.
And it's telling us the diameter of the moon is 2,160 miles.
It doesn't sound right.
No.
Let me see what they're saying it is now. Maybe it is right.
Diameter of the moon.
Now they're saying it's, 2,159. They were a mile off.
All right. I will let them have that.
But how could Kepler come up with the second law of planetary motion, which says planetary bodies move faster when they're closer to their gravitational partner or their whatever they're revolving around than further away? How could he do that based on Mars without a telescope, and Earth is moving at the same time? So can you tell really when Mars is speeding up and slowing down? Does all these retrograde motions and things like that. I'm sure there's excuses for it. So it's just, to me, it makes no sense. But the moon blows it away. Absolutely. Dave Marsh's moon observations. Oh, you want me to read what I'm going to cover at the Flat Earth Convention?
Yeah, that's coming up soon, isn't it?
Yeah, I'm not speaking, but I'm giving with Dave Marsh a presentation. We're going to combine and do a moon presentation. But the following different things, I'll just read them off, to me, bust NASA's moon you know, or bust the science to all to hell. The first thing, now this might not be in order, but the eclipse path, 2017 versus old data. I don't know if you remember looking at that, but all the people were arguing, and I didn't make a big deal of this. But people were arguing that the eclipse path went from west to east. It started on the west coast of the United States and went east. And everybody was saying, how could that be possible? Because the moon moves east to west and we're spinning towards the east. And you remember all that probably. Pardon me just a moment. I'm going to look up a eclipse map. And what most people don't know, I'm going to say it here for the people who don't know so they can tell others. Eclipses are not based at all on the orbits or positions of the planets or the moon. They are, generally speaking, 19-year charts that have, if you observe the moon and the sun, or I'm sorry, if you observe solar and lunar eclipses and you mark them down and where they occur, they will all repeat themselves again. At so many, like 23.254 years, it'll happen again. And it'll have to be adjusted 8 degrees north, whatever. These people have known this since pre-Christ times, including the Mayans. And I always bring this up because it's fascinating to me. The transit of Venus, which is Venus moving across the surface of the sun as viewed from Earth, was predicted exactly to the day by the Mayans, who were flat Earth believers. In 2012, they went all the way up to 2012. They predicted that transit of Venus across the sun. Not only did they predict it, but there was only 2 places on Earth it could be observed, and that was absolutely correct. And they got that over 2,000 years ago. They predicted that 100% correctly. So people say the proof of the globe is eclipses. No, that's proof that people know how to write things down and recognize a pattern. I'm looking for a map to show why I'm talking about this eclipse path. For those who haven't seen it, I probably won't pick the right one, but I'm going to screen share again, Karen, if that's okay.
Yeah, sorry, I'm here. Yeah, go for it. I'll just move it over for a sec.
Okay. Copying an image first. Let me paste it in here. Get rid of Soundly's work. And almost ready there. Uh-oh. We have 60 watching. Your channel should have 600 watching.
Especially because you're on, Rich.
No, not especially because of me, but there's so many things that you all cover. It's just fascinating and fantastic.
Thank you, Rich. Anyway, it's you lot who come on who make the Hangouts.
Okay, here we go. Yeah, that's the trick. You got to go to Google to do it. Fascinating. Anyway, the path of the... everybody was arguing in my video that the moon was only 70 miles wide because you can't cast a shadow. Any object, the shadow it casts can't be smaller than the object. And boy, the cognitive dissonance on that. And by the way, that's got 500,000 views now. But here's what I say to that before I get into this. If all you have to do is, there's no theoretical thing about it. Use sunlight. Go out when it's sunny. Get a basketball and a baseball, or 2 different size balls. Have the smaller one cast a shadow on the bigger one, like the moon casting it on the Earth, using sunlight, and see if you can get a shadow from that smaller object to be, from that object to be smaller than the object itself. You won't be able to do it. So since the shadow was 70 miles wide, if you say it's the moon that was blocking the sun, the moon cannot be wider than 70 miles. It just absolutely destroys physics. So anyway, the eclipse path was generally like this, west to east. And people were saying it has to be. That's the way it always is. Well, what they don't realize is that there are eclipses that don't follow that. For example, well, this was going west to east, but you see how it heads further? It's more of a southeast, and then it turns due east, and then it goes northeast. Well, in reality, if you think about this, if the Earth is spinning towards the east, and the path is heading east, well, that is faster than if the moon is heading south or north. Why? Because it's covering the same distance, but not heading with the direction of the spin of the Earth. So the moon would have to be speeding up and slowing down all through this curve thing here. Now, up here, let's see if I can come in on it. Here is an eclipse that happened in October 1986. Now, how do they know this? How do they know this is the middle of the freaking ocean in 1986? And trust me, I can take these maps back to 450 BC, and they'll have stuff just like this, where the path is right in the middle of the ocean. And it's like, well, how did they know that? That's because it's a repeating pattern. Nobody was out in the middle of the ocean back in 450 BC writing it down saying, oh, for future generations, here was the path. We followed it the whole way. Please. But here, this started here, moved west, then southwest, then due south, then towards the east. So eclipse path alone prove it's not the moon. Wow, I didn't know I could do that. Here we go. So you have all these different paths, and I actually had a challenge one time because there was one over Russia that did this type of thing, and they claimed that it was the sunlight coming over the top of the poles over causing it. But it was an equinox state, so it was impossible, and they admitted it was impossible. Go ahead.
I'm just trying to think, who was it who's done it? Banjo, Flat Earth Banjo. You've seen him. He's been doing some work on eclipses and stuff. These eclipses, like you're showing now, these graphics, we can all see them. But if you put that graphic on a flat Earth, then it makes sense, because you've got these perfect little circles that these eclipses make. Or not perfect circles, but they're circular. Let's just say they're circular anyway. Not these squiggly lines like what you've got here.
Your earphones are making a noise. Don't touch them.
I'm not. Well. Yeah, but I was just saying, Flat Earth Banjo, he's done a lot of work on eclipses, showing you that the pattern of an eclipse isn't this swirly line like what you've got there. Yeah, they can complete circles, egg-shaped circles, kind of. But yeah.
I'll look that up. I will. Thanks. But this absolutely just, all these different paths, the Earth doesn't all of a sudden on eclipse days start going faster and slower or shifting directions, and neither does the moon. So the people that were so adamant and given the mathematics and everything why the path was going west to east, and if you remember, our path was pretty, what's the word I want to use? It was pretty standard. It wasn't any kind of a huge deal. It was, let me pick a different color. What's on here? I wonder if yellow will show up. It was pretty much like this. But when it got out in the Atlantic, it started curving like that type of deal. Let me give it a darker color. There we go. And it's not exact. This was actually a little bit further north. But the excuses were crazy. The video wasn't even about that, but I just showed how NASA dumbs you down at the beginning. They were showing people spinning around with this crazy music and showing how can it go west to east when the Earth is spinning west to east? And you had two people spinning around one another. It was absolutely ridiculous. But of course, all the globe earthers were just absolutely, no, the models, that's it. It's got to move west to east. And here's why. Oh, then why does it move east to west and then due south? And why is the path so small here? It just, there's all kind of, as you can see on this map, there's all kind of different squiggly lines, different directions, the moon, so to speak, but it's the path. And look at these paths. All right, the widest path is probably this one, these two down here. So was somebody in Antarctica to observe this? How would they know this? Oh, they use planetary observation. No, sorry. This is just data that's repeated. So anyway, that's the one thing. Moon and tides, we already covered that some, where there is no there's a correlation with where the moon is, but it's not a gravitational correlation, because when the moon is, for example, closest to the east coast of the United States, you don't experience high tide like science says, you experience low tide. But in Spain, at the exact same time the moon is closest there, you do experience a high tide. And at some other place on the earth, say Turkey, the moon's got to be in between being closest and furthest away for you to have the high tide. So there is a correlation with the moon's position in the sky, but there is no correlation gravitationally. Candlelight and moon and fire, and I might try to pull that up. That was very interesting. And I might, there's so many things I did early on that I wish I would have done later, because I understand so much more now. But what I want to do is I want to see if I can find. Actually, what I'll do is I'll stop sharing for now and try to find that video, because I want you to see my friend Dave, who lives in Wales. Oh, by the way, how far is Wales from you, Karen? Cardiff area?
That's a country away.
A country away, huh? Now, as far as
it's only a few hours, Rich. I would say on a train from Cardiff, from London to Cardiff. Don't quote me on this. I'm guessing about 4 hours or something. It might be even less than that, but I would say about that. If anyone in the chat knows better, please let us know.
Yeah, I didn't think the UK was that big. 4 hours. But I guess it is. It's just you have this weird perception of stuff when you're not there. So do we have any questions?
I was muted. It depends which part of Wales you're going to, but the Bristol is about an hour away on the motorway, and the Severn Bridge is a few miles round off there. And that's the bottom part of Wales, where Cardiff is.
Okay. Yeah, because I think Cardiff is near the area.
It's not that far then. I thought it was further. Sorry.
So how far did you say, Karen?
It takes about an hour-ish to get to Bristol, which is not far from the Severn Bridge.
All right, that's I was thinking an hour or two, so that's more in line with what I thought. Now, how would I get from the UK to you, Astral, to Denmark?
How would you get to me? Are you a good swimmer? Well, it's
not
pretty flat
cold
anyway.
water.
Actually, I think it's going downhill from England to Denmark.
Hey, that's a good point.
You'll be laughing.
Yeah, if it's like that bridge, all I have to do is go halfway, then drift downhill the rest of the way.
Yeah, just get a little bodyboard, man. You'll be fine. It's not far. It's a little flight, man. It'll take you an hour from England if that's the case. Otherwise, if you're going to drive, well, yeah. How long does it take, and where you're going to go, and what do you want to see?
You go to Aalborg Airport, and that's very close to Astral.
Yeah, that's it. Aalborg.
Say that again.
It's
How about
fly to Aalborg, A-A-L-B. Go on, Astral, B-O-R-G, Aalborg.
Correct.
Aalborg.
Correct. That's correct. Yeah.
I've been to Aalborg a couple of times. I have a Danish friend who lives right at the top of Denmark, probably about, I don't know, about an hour from Astral, maybe a bit longer actually, probably about an hour and a half from Astral, to be honest, by the time in the car.
It's about 2 hours from me, 3 hours to the north of Denmark from where I live. By
is
driving.
it?
Yeah, it's
Aalborg
far.
Airport's not that far from you, is it?
But again,
No, Aalborg's about an hour away, maximum an hour.
Right, okay. She's an hour and a half on up the other way.
So how would I get from the? I mean, what I'm talking about instead of time is what would I do? Train or? At some point we got to cross water, right?
Yeah, You've got to cross water. So either you can take a train, you can take a car and take the train to Dover, from Dover to Calais, I mean, and then drive. Or you can take a train from mainland Europe, anywhere you want to go, like, it goes for every city. Or you can fly.
Okay. I've got this queued up now. I'm going to share again, Karen.
Okay.
So I get there. There we go. Did I cut it off?
Yeah, you cut it off.
Okay. All righty, here we go. This is an old video from April 14th of 2016. Now, Dave in Wales did this. What he did was, it was a full moon, and he had candles. I think it was 3 each. 3 on, he had a partition in the middle where the moonlight could not get to these 3. And the 3, of course, on the other side were exposed to moonlight. And play this here for a second. These were the candles that were in moonlight. And look how the wax was all gone. And then let me see if I can find them in the shade. Actually, there's more than 3. See the candles, how much more wax is on them? And there's the shaded. Oh, actually, what happened was it was the opposite of what we thought. We know that moonlight is cool, and that so what we expected was that the moonlight side would have more wax. I'm kind of confused in my head now because it was so opposite of what we thought. So at first we thought it was a failure. We were like, no, moonlight must be like the sun. But let me read this here. When you cool down the surroundings around the candle, more heat is transferred away from the pool. This is from science. More heat is transferred away from the pool of melted wax around the wick. You end up with a smaller pool of melted wax. The distance that the molten wax travels from the edge of the pool to the wick is shorter, so there is less opportunity to heat up the wax. Therefore, the viscosity of the wax at the base of the wick is higher. The resistance to traveling up the wick is greater, so there is less wax fed up the wick. The flame in a cold environment would, for that reason alone, be expected to be smaller. So the flames on the moonlight side were actually smaller. Also, the fact that you are adding cooler air into the decomposing wax would also tend to slow down that part of the overall combustion process. I would submit the lower temperatures cause an increase in wax viscosity at the base of the wick, slowing the amount of wax which travels up the wick and causing the candle in a low temperature environment to burn more slowly. So the moonlit side burned more slowly.
It makes sense, that, in a sense, doesn't it?
Yeah, but what was cool was this was from mainstream science, and it was the opposite of what we thought, but it absolutely 100% went along with our observations. And these are the actual scientists that came up with the paper, and there's the link, sprott.physics.wise.edu/demobooks chapter 2. But it absolutely proved that the moonlight was cooler than the other side, the block side. So anyway, that I got to go through that video again. It's old, and revisit it and know what I know now, but that's part of one of the proofs I'm going to show. Everybody's done the temperature test, or a lot of people have. Some people have used magnifying glasses. All of it, at worst case scenario, shows no heating. I mean, there's absolutely no heating at all from moonlight. But the vast majority of those cases show a cooling with moonlight. The other thing I'm going to cover is this so-called earth shine, where during lunar eclipses, we all know this, it's supposed to be a red shadow, which I still, maybe I should put out like a $10,000 reward. If you can show a red shadow or cast a red shadow, I'll give you $1,000. Maybe I should do some kind of reward like that. Because there's no such thing as a red shadow, except for in lunar eclipses, of course. Here we go. Ah, the BBC. Going back to the ancient Mayans and the ancient Greeks being able to predict eclipses, they also were
They
able to.
don't like any of their stuff being shown, though, do they, Rich?
No.
The bullshit broadcasting corporation.
But you've noticed, I'm sure, from not only observations, but from different videos, that there are different shades of red during different eclipses of the moon. Some are brighter than others. Some look like a really dark orange. Some look blood red. The ancient peoples could tell you exactly what shade it was going to be. Isn't that amazing? Now, how can they do that with orbital mechanics? But here's the deal. We see crescent moons once every month, with just a little sliver of the moon lit over here. And sometimes we get a little, whatever it is, reflectivity or something where you can see the rest of the moon's outline, but it's never red. You never get any red at all, no matter what phase of the moon is. You never get quote unquote earth shine that turns red like this. But during an eclipse, according to NASA, it's sunrises and sunsets all over the earth casting red light. See, they've changed it. It used to be casting a red shadow. Now it's casting a red light on the moon. Well, it's like, how come we don't get this red light on the moon during the crescent, when during a crescent, most of the moon is facing a lit earth, just like during an eclipse, or just opposite of the eclipse. Or when you get like the opposite side, when you have a waning crescent on the other side, most of it is on the dark side of the earth. How come there's never red? See, these things don't make any sense. On the one hand, NASA wants to say the red on the moon during an eclipse is caused by sunrises and sunsets being cast onto the moon from the earth. But yet sunrises and sunsets, as far as I know, still occur during crescent moons, and yet we never see that cast onto the earth. So that's another thing we're going to cover. I'm also going to cover the different deltas, or the different percentage changes in the growth of light on the moon. And most have probably seen that before if they follow my channel, where you might have 1%, let's say 3% light the first day, then 6%, then 9, 12, 15. Well, it doesn't work like that. It's more like 3, 6, 7, 9, 15. And then it even backs up in some cases, 14%. How can you have 15% of the moon lit, but then the next night 14% when it's growing, when it's waxing? Those things don't make sense. The next thing is the distance to the moon, thought to be in 1969. I'm waiting for that world book to come in. I'm going to show the lunar wave by Crow 777. The flip of the eclipse, Karen, that you sent me, that video, the flip of the eclipse in Mexico.
Yeah.
Who was it who did the rock and roll moon? What was the rolling moon? It was Skyfly Bride, wasn't it? That video. That was an awesome video.
Oh, yes, that's fantastic.
He says he's got another one he was putting up on his channel.
Yeah, that's got to go mainstream. I'm going to cover that in a video. Because what we need to do now is we need to get observations that verify that what they're saying is correct. And
I was just going to say, I've always had a problem with the moon, the side of the moon that we see. Why are we only seeing that side? And they're saying it's because it revolves at the same rate as the Earth. The Earth isn't revolving, idiots. So why we see that side of the moon?
Well, you know how they get it to work out mathematically? They say the moon is rotating at 10 miles per hour. Freaking nonsense.
Yeah.
So anyway, I'm going to show that flip of that. Plus, I'll probably show the flip of the solar eclipse also,
Yeah,
Karen.
Happens in the meridians.
Yeah.
Capricorn, Cancer.
But
So
yeah,
I mean that blows it, doesn't isn't it? How does all that work then?
It doesn't. It doesn't work in the globe model. It's absolutely impossible. I'm going to show the different colors and landscape of the moon of the USA versus China missions. I mean, it's a totally different looking surface. And you could say, well, maybe because they landed in a different spot. But you know, the Apollo missions, they landed in all kind of different spots and filmed the whole thing. You know, like supposedly filmed the whole side of the surface of the Earth from of the moon, rather, from just above the surface. That's another thing. They never filmed the Earth. You know, from the somebody said in a comment, you know, why didn't they leave a camera just constantly, since the moon is constantly facing Earth, just, you know, set up a tripod with a camera that broadcasts back to the Earth from the moon, where we can have a 24/7 view. And because that's not there, that's a red flag right there. I'm going to show some of the anomalies of the craters, what I call like an Audi belly button, where some of the craters are inversed. Instead of you have a divot in the middle, you have a pimple in the middle, so to speak. I just saw someone who showed a nice picture where it was two craters, one on top of the other. And his question was, how is this possible? How can one crater land on top of another? They were a little offset from one another. And yet the crater underneath wasn't damaged whatsoever. It's just unbelievable stuff that just doesn't make sense. This is a big one for me. No blue light around the moon. Sunrise and sunset, it's barely light. And I just noticed this again. This time of year is perfect for observing this too. It was blue from one end of the sky to the other, but it was dark enough to where I could not see my shadow at all. Yet the entire, even the east part, this was sunset, even the east part of the sky still had blue in it. Not a lot, but it was still blue, not black. And then a little bit later, full moon, I can see my shadow, much more light, not a twinkle of blue, 100% black. If it's reflecting sunlight, we should get at least some blue in the sky, and we don't. Contrasting the two different, what's the word I'm looking for? The two different spectrums of light. The sun, of course, being from the red spectrum, which is why we get a little bit of a yellow tinge. And I do agree that sun was much more yellow when I was growing up than now. And the moon, which is absolutely not of the red spectrum, it's of the blue spectrum. And that's why we get the silver light from the moon. So those are just some of the things we're going to cover. And then Dave's going to do his presentation. And I think with the combination of those two, I'm hoping some media is there, because I think that should convince some people that something is definitely wrong with their model. And so with that, I'll end the screen share.
Oh, 1 second, just make sure. There was a question for you here. It's gone a bit up now. Where is it? It was, where's it gone? Astro King. He said he's got something for you. I can't find it now. 10 reasons why the Earth's orbit, but I've lost it now. In the chat room. Where's it gone?
Maybe he could repost it.
Yeah, I'm sure he'll email it to you then. I've asked Astro King if he wants to come on Sun and Moon as well, so that'll be good.
Yeah,
oh, that's
that'd
it.
be cool.
Can you let Rich know I have a PDF on the moon orbit and 10 things about controlling orbit?
Say again, please.
Yeah, he said, can you tell Rich I have a PDF on moon orbit and controlling orbit?
Oh yeah, I'd love to see that. If he can write me at peopleforpeople.life/Rich, that'll give me his email address, and I'll email him back. He'll have my email address then, and he can PDF it to me, or he can put a link in the contact form that's there, and I'll definitely see it.
Okay, don't know why it's zoomed on me. Sorry, the camera got caught on me. Ian asked, would you please ask Rich if any persistence has paid off, and has and has now looked into the telescope collimation, yeah.
Is that in regards to Soundly's photograph, or
I think so.
who's asking the question?
Ian Matteson.
Oh, okay. Yeah, Ian, I got your information, and that makes perfect sense with what the woman told me before I started videotaping, which I haven't talked 100% about because I don't want to reveal it all. But I think you're talking about the adjustment of screws, so to speak. Even if the screws are not adjusted, what he's talking about there is what Soundly did evidently was he took a P900 or P1000, whatever, and he did not zoom that whatsoever, but then he attached that camera to a specific telescope. And there is a way to do that where you can get what we saw. I'll just leave it at that. So yeah, I fully get that. And what I think is going to happen is I think I'm going to go down there. I don't think he's going to show up with his equipment. But like I said, it doesn't matter. I've got some, I think, pretty good ideas for, well, let me just run it past everybody. Here's what I'm thinking about doing. There is a drone that has red and blue lights on the bottom. And it's got an automatic feature where you push the button and it automatically goes 15 feet above wherever you're standing. So that's a known height. And of course, I could always adjust that. But I'm hoping to film that from the other side of the lake, just 15 feet off the lake, with another person there at night, and some other things too. But I think a drone is going to be an interesting way to do that. A drone also will allow me to do some other things, I think. I think it'll allow me to take a sling psychrometer, if I can get one not too heavy, go over the water and get me the readings of the air density there as well. So there's a few things I'm thinking about doing as far as experiments. Maybe 2 balloons, and I don't mean the gigantic weather balloons. Probably more like kids balloons. I'll probably see if I can rent a tank of helium, blow up about 10 or 15 kids balloons on either side, and put those on a tether, put them on a line, and raise them up 5 feet at a time on both sides of the shore. Have people on each side shoot towards the other, and keep going up 5 feet at a time until the camera sees them, or down 5 feet at a time until the camera can't see them, across 24 miles of lake. So that's another idea I have as far as doing a flat earth, besides the regular video stuff there. I'd be interested in, one thing I would love to do, probably won't be able to do it at Lake Pontchartrain, but probably at the Puget Sound I can do. And maybe even local to me, or fairly local, which is the Salton Sea. I don't know if they have boats there that you can rent, but my son, who doesn't believe in the flat earth, had an idea. He said, why don't we go out on a boat and have a laser pointed at the back of the boat and see if we can keep that laser on the back of the boat all the way across a lake. So I think that would be a pretty decent thing too.
Can I say something, Rich?
Sure.
Similar thing, but this is to do with using a heliograph, which is a mirror with a hole in it, right? You know that, don't you? A small mirror about the size of a credit card with a hole in the middle of it. And what you do is you have one, you're facing obviously the sun, and you use the sun to reflect, looking through the hole in the mirror at your target object. Now, they probably cost about £1 or £2 for one of these. Now, if we get people to purchase a heliograph, we can set up a chain of flat earthers that are flashing these flipping, you know, can you see this? Oh, I can see a flashing light. And then they will then flash it back or turn around 180 degrees and flash it to whoever can see it on the opposite side of them. Do you know what I mean? So you make like a train of people that are each flashing a signal across. Now, if you can see signal from A to B and from B to C, I'm not saying that that's going to be flat, but you know where I'm going, don't you? We can obviously get some sort of distances going there, and that we can record it and say, right, He's over there, and that's 12 miles away, and I'm seeing it here. And I'm, 2.7 meters above sea level, whatever, It's simple enough to do, and it's cheap enough to do. You don't need a laser. You're using the sun. If you've got the sun shining, I mean, you're in America, you're in Arizona or whatever, yeah, it should be easy enough to replicate over there. Yeah, I'll yield the floor.
Can I say something? We had an idea on Sun and Moon Facebook group a while ago, was to every day at midday for you, point your camera north on the phone or whatever you're going to take it on, and then take a picture of the shadow at where the sun is at noon every day for you. And then that would show where the shadows were for everyone and where they're supposed to be. And but anyway, we did that one for a while. It's a while ago now, but at 12 o'clock, everybody on their day. But you see, we don't get our sun every day, do we? So in America, like Arizona, you'd be able to capture it every day practically.
Yeah.
There's another idea for an experiment. Again, maybe other people can do that. It's quite a good one. You'd know where everybody's sun was then, wouldn't you?
That's true. I think it's all going to be local anyway, right?
Yeah. Somehow.
Well, what do
it is.
What do you think of this? Why is pardon me, I got to take this call. I'll be right back. Hello.
Yay. I think he's muted for a moment now. Yeah, is Patricia there? Patricia. Oh, he's back now.
Sorry about that.
That's okay. Yeah.
Oh, what I was going to say was, why? I mean, see what he just suggested, like with the heliograph. I've seen a video where someone actually had a mirror sitting on the stinking water on the other side of the shore. I think it was 7 miles away, and his wife on the other side got the flashes and recorded them. But why is Stanley going over water to prove that the Earth is curved? Why can't I go out to the desert and just film something 30 miles away? And the answer is simple, because that won't be accepted, because everybody in the back of their mind accepts water as flat. So that's why all these films, and even by the globe people, all these videos, they're all shot over water, because water is the one thing I think we all agree has to be flat, whereas ground, you can always, it goes up and down according to sea level, but sea level never changes. See, when you have distortion in a video like that, what that is showing is over that short of a distance, you've got a, whatever it is, let me go back to the flat Earth calculator or the curve calculator, at 24 miles roughly, you've got a drop of 384 feet. So you half that, 192 feet. The water in the middle's got to be higher than on the edge of the shore. And yet the whole thing is 12 feet above sea level. So are we saying that, I mean, think about the impossibility of that. So you got 194 feet higher water in the middle. It doesn't know, because gravity's pulling straight down on it. It doesn't know it's higher than the water surrounding it. It's the only place on Earth that doesn't know that. But think about that. In just that short period of time, with a total drop of 384 feet, that's from one to the other. That's the extreme. You've got a 384-foot difference in sea level. So, I think there's another way to prove this with the barometer.
It's kind of ironic that we're beating ourselves up over this to try and prove the Earth is flat. It's flat. It is. There is no getting around it. I mean, we've tried looking for curvature, and we've tried finding movement, and it ain't moving. There's no curve, But we're beating ourselves up every single day, trying to find. We ain't gonna find it.
Yeah, try to find that bed in water.
There
isn't any.
We're not gonna find a curve as long as I got a hole in my butt. Sorry to say, but we're not.
I mean, another proof just came to mind.
What's that, Rich?
Wow. Barometric pressure again. Like I said, on the ship, we had to reduce our barometric pressure, even though we're only 100 feet above sea level. We had to reduce it to sea level so that the planes could land correctly. And there was a difference. I can't remember how many millibars it was, but and that changes a little bit depending on where you are. Hard to explain, but here I'll give it a shot. If at the lake, let's say that bridge wasn't a bridge for cars, but let's say it was a runway for aircraft. Wow. The barometric pressure at 380 feet difference from the middle of that bridge to shoreline, or let's take half of it, 190 feet. 190 feet is going to be a big difference in barometric pressure than on the shoreline. But we know it's flat, so there isn't going to be any difference. So I can go with my app. Let me find it here, show you. This is going to be a proof. Let me see if this shows up well. Now, is it reversed? It's probably reversed. The number's at the bottom, but
No, it's okay. It's the right way round.
is it really?
Reverse for you, but fine for us. Yeah, we can see
Okay.
that. Nice.
All right. So anyway, it's telling me my station pressure, which is where I'm sitting, is 971 millibars. All right. But the top number is 971 millibars. But look at that bottom number, 1014. That's the sea level barometric pressure if you reduce it. Now, if I take this app and I'm standing on the shore or just getting ready to drive on that bridge, and I take a barometric pressure reading, which is 12 feet above sea level, it should be barely an adjustment. But by the time I get to the middle of that bridge, where all that bulge is, or whatever you want to call it, there should be quite a bit of difference between my station pressure and sea level. You follow? It should be much different than at the shoreline. I don't know if that makes sense or not. But if I was to take this app, and I don't have a second story here to the house, let's say I was in an office building right now and I went on an elevator. Each floor I went up, there would be a greater difference between the top number and the bottom number. If that makes sense. It has to be. Because as I rise, my station pressure will drop, but the sea level pressure will not change. So if I go across the middle of the bridge and I get the same reading virtually as I do on the edges, that shows there's no rise in the middle. It's all level. And this thing is, yeah, and this is, I mean, I can just rise it up and I just got a 0.03 change in millibars just by rising it up that far. So the length of my arm. Yeah, this will be another experiment I do there. I'll have to draw that out so people can see it and understand it. But you can't say you have a different sea level at the middle of that than on the end, because planes would be crashing constantly.
I was just going to say that would actually be a very good experiment, you know, because obviously you're going to combine with the middle of the bridge, and like you say, it will show it 100% what the pressure is, you know.
Now, when I go up those 90 degree, or they're probably actually 20 degree or 30 degree. When I go up that part of the bridge that allows boats to go under.
When you climb up the wall, you mean?
Yeah, exactly. Well, yeah, when I go up those, that should show a drop in the pressure versus the station pressure. I mean, versus the actual barometric pressure, which is beautiful. Oh, that's all beautiful. Because when I'm not on that going across the bridge, I should see that changing, getting lower, or getting a bigger difference between the two numbers. And then when I go up on that part, it should really change rapidly. So here's my prediction. I predict the Earth is flat. I'm going to basically see the same barometric pressure the whole way until I go up on those things. Then it'll change. And then when I come back down and get level again, it'll be the same as before I went up on the little hump on the bridge. That'll be a proof right there. Absolutely. And you can't say there's that much difference in sea level. It would never work. Planes could never land using an altimeter. Because, I mean, if you have that much difference in sea level going across a bridge, which you'd have to have, you'd never be able to get your altimeter to work right. Anyway, just something I came to mind as I was thinking about all this. So, any other questions?
Oh, couldn't unmute myself. Yeah, any more questions for Rich in the chat room? You've made him think even more now. You've got another little project to go on now, haven't you, Rich?
Well,
Yeah,
it's not
another
it's not a question, Rich, but I was just going to say that when you do this barometric test, take a real barometer with you, or 2 or 3 if you can, you know, like real ones, not just your app on your phone, because then at least you can say, I've had 3 different barometers, I've had my app on my phone, and this one is showing this is showing that, this is showing that, and my phone is showing this, you know, whatever, just so that, you know, either they're all the same or there'll be whatever difference, you know. But at least it's going to show more of a true reading, isn't it? If you've got more devices that you're taking readings from.
Yeah. Well, I could take what's called an aneroid barometer, which is what most people have today. I can also set up, wow, I haven't done that in a long time. You can get a can, and what you do is you heat up the can. So all the, so you create a vacuum in the can, and you attach a tube to it. The tube flows into water. And what will happen is you color the water with like red food coloring, and the water will suck up into that tube. You have to have a long tube, and then it'll fall back down to, let's say, 30 inches, roughly, which is the millibar, 1,000. What is it? 1012 1012 millibars is roughly standard atmospheric pressure, if I remember right. Which is equivalent to 29.96 inches of mercury. But it's a little complex, but I can do that. That'll fall back down to like 30 inches. But you also need to have a separate one which measures your temperature in the room, because as the temperature rises and falls, so will the barometric pressure. So there's a correlation you have to do between the two. Boy, I have to think that through. I haven't done that since I was, 17 years old probably. But yeah, I used to have that. That's the kind of science person I was. I would have an aneroid barometer, but I also would verify it against that type of barometer, which I can't even remember what it's called. But that was the barometers they used before the aneroid. But you always had to correct for temperature. I'm trying to look for a calculator here that would allow me to rapidly reduce pressure to sea level.
And Chris says, thanks for clearing that up. Was that someone he's talking to in the chat room, or you, Chris? Rich?
Okay. I don't think I heard a question, so I couldn't clear it up unless I happened to hit it.
So you're getting all excited about the convention now then, Rich?
I'm excited about seeing Denver, but I understand that see, Denver or Colorado is a very, very beautiful state, so I've heard. But Denver, I talked to my brother yesterday. He's been to Colorado quite a few times.
I think, Rich, you're going to need to take some woolies.
Take some what?
Woolies, they're called here. Jumpers, scarves, hats.
Oh, yeah, I'm going to be freezing. I really will be. But I'm hoping somebody I know there has a car and will let me drive, or they can drive me west about 45 minutes. My brother says that's where you get into the beautiful stuff. Astral, I'm looking on Amazon and I can see all these different instruments you can buy. This one does temperature, humidity, digital pressure, altimeter, night vision, measures barometric pressure and trend, altitude, wet bulb temperature, heat stress index, relative humidity, dew point temperature, and wind chill. Maximum wind speeds. Wow, this is $193. I didn't want to spend that kind of money, but that'd be awesome to have. Anyway, I will look at stuff like that to see what I can get.
Might be able to find a cheaper one.
Yeah, like I said, I definitely want to take a sling psychrometer. It looks very crude, but like I said, for under $10, you can get as accurate as a $500 instrument. And that's always the argument. Once you prove something that goes against the globe, oh, your instrumentation isn't good enough or whatever. I've heard that before too. You remember when I did the moon? If you people that watch my videos, I did the moon temperature test. At first, I did the electronic point and shoot laser type of thing. And the argument was, oh, that's not good for that because you're really getting a larger diameter than what you're actually covering. So then I got, what did I get next? I got digital thermometers. That wasn't good enough either. You know, you have to get the actual old style mercury thermometers. It's not accurate till then. So it just goes on and on. But you know, it's time soon to shift from, you know, I like it when new converts occur because of my channel or whatever. But it's going to get to the point where I don't care if you're a convert. I really don't care if you're a convert or not now, but it's nice when it happens. But it's going to get to the point where we're just going to have to say, look, the Earth is flat. It doesn't move. Let's move on with it and get down to some 3D chess, so to speak, versus what we've been doing. I think you were alluding to that earlier too, Astral.
Yeah, because we have to walk around with the globe and the flat, if you know what I mean, to tell a globe person.
I'm just wondering, right? I know that they're still producing globes nowadays. I've got a friend. He has an antique shop, about 4 in there, and I said to him, "Pull off the flipping vinyl that the map is on, and you'll have a little ball with a lamp inside it, and that lamp will be awesome in a living room, man. Because with a map on it, it's shite. We know it's just a toy, but with the map removed, you've got a nice lamp there, a little globe lamp. Seriously." Clear bulb, clear, yeah, a clear little, yeah, lamp. Rich, what I think people need to do is experiments, but using old equipment, modern equipment, using old methods, using newer methods, so that this way we can, you know, say, right, well, I've done it the old-fashioned way. I've got an astrolabe here. I've done it the modern way. You know, I've got my telescope here, my P1000, whatever. We've got mercury in a thermometer. We've got alcohol in a thermometer. And I've also got on my iPhone or my phone a thermometer. You know, we can do it different ways. We can take measurements in so many different ways, analog and digital. And that's probably the best way, because then we're covering all bases. And this way we can say, these are the readings that we've been receiving from this apparatus. Now you what do you make of that kind of thing, you know?
Yeah, absolutely. But like I said, the reason for moving on beyond worrying about what the trolls think is once you present everything you just said, there's always something else. And that's fine. You know, people want to remain in their own cognitive dissonance, which goes back to the education thing that I was speaking about. That's fine. People believe what they want to believe, and people believe what they believe, and they don't even know why they believe it. Why do you believe the earth is round? What proof do you have? The people, they can't answer you. The vast majority cannot answer your, you know, why do you believe it moves? I've seen pictures of it, or I've seen, you know, satellite images. There is, you know, we've got 2 generations in a row now that don't think. Welcome back, Patricia. She dropped off for a minute.
Yeah, she's always there. Sometimes when I don't think she is, yeah.
Yeah, but I'm really looking forward to working with Dave up there. Back to you, what you were saying, and meeting some people that say they're going to be there. But
Dave had Ditcher on. He's looking forward to it. Obviously, Alex, the Music Conspiracy, he's gone a bit quiet now because he's preparing himself for it. Because he's singing. Obviously, Dave's going. He's well chuffed and excited. Yeah. Everybody's excited.
yeah, me and Dave are actually going to be there the same day too. We're going to be 2 days early, I think. And I know the night before, I think there's a hangout. We're all getting together at a bar or something. That's going to be fun. So,
Yeah.
I just barely spoke to Dave last time in North Carolina last year. So we were both busy, and I had other things going on, and I wasn't into the social thing last year, but I'm in a totally different mindset this year. So I'm really looking forward to getting to know people. It's too bad you're not coming, Karen and Astral and Patricia too.
Yeah. It's a lot of money for a few days. I'm really sorry, Rich.
Well, never say never, because if I get the money to go, I'll go, definitely.
Yeah, if I suddenly got some money, I'd go.
I wonder how much it would cost you to come here.
Oh, yeah. Bling Bling's going as well. Hoary Sheet's going. Hoary Sheet Show.
Oh, good. I want to speak to him about how he does his live green screens.
Hey, Ditch is in the chat room. He says, looking forward to it.
Good. Yeah, anybody wants to see me, look me up. I'm thinking maybe one night, anybody wants to, we'll go out to dinner somewhere and just have a nice round the dinner table talk.
Mm.
Of course, it probably have to be, unless somebody has a car, it would have to be at the hotel. I won't have a car. I'm flying in, and I'm not renting a car.
Hmm. Well, you put that one out, Rich.
But I think it'll be cold. Let me see what Denver weather is in November.
Cold.
Little different than Phoenix. 57 high, 27 low. And they only get 2 days of rain? Hey. Let's see New Orleans. See if I'm right about the...
What 2 days does it rain there?
I guess the average 2 days of rain in...
Yeah, which days?
Really,
which?
Yeah, really.
Dude.
the two I'm going to be there. All right, now. Let me put January. Now it says 7 days. Now maybe that's in a week. So you get 7 days of rain in January in New Orleans. Okay. Now when I want to go in May, or what did I say, April? Oh, got nothing. Hold on. It won't give it to me in April.
Too far ahead.
You know what? That weather app is probably about as reliable as our internet of late. You know.
Yeah. Let me put May. Wow. It gives it to you in a nice little format where it tells you how many days it's going to rain, all those months, but it doesn't give me those two. Anyway. Yeah. Anyway, I know the difference. Like I said, in April, it's going to be more showers and thunderstorms that'll pop up in the evening, and it's going to be more of a steady type of rain that happens in January. So I'd much rather take if I'm going to spend $1,000, I don't want to go there and have 3 mile visibility for the 2 days I'm there. It's just doesn't make sense for me to risk that much for that little chance. I mean, Phoenix, there's no problem. I mean, there are certain times of the year where you have more chance of rain than others, but you can almost just come any day you ever wanted, and it's going to be sunny. I think I've been here since 2008, and I think there's only been 4 days, 3 or 4 days, where the entire day I didn't see any blue sky. Think about that. I mean, that's even when it's
Well,
raining.
you come here and you can never see the blue sky, Rich.
Yeah.
Can I just say, how do you think about all those things? We were talking about it briefly on a back chat about, like you can actually order the weather. Like for a wedding, you can make sure there's no clouds and that. What do you reckon to that then?
Maybe that's
You know,
insurance.
you just release things in the atmosphere.
There's no way to
Yeah.
guarantee it.
They've been able to do it for ages. The Chinese were like firing up fireworks years and years and years ago with certain chemicals in, and they could make it snow. You can actually make it snow yourself. You just have to have the temperature and spray a hose pipe in the air. You'll get snow. You can do it yourself. It has to be I'm not sure what the temperature exactly is. It's around freezing, but not freezing. And you have to have a certain air, what do you call it? Fuktigkeit.
Yeah, what they're producing
wetness, yeah. But
yeah,
you can produce your own snow.
Yeah, it's actually ice, little shaves of ice they're creating. It's not really snow. The difference, how you get if you're interested, how you get snow is it's actually a miracle of nature. You need what's called supercooled air and supersaturated air. And what that means is everybody knows that when there's 100% humidity, the air cannot hold any more water. But under certain conditions in the clouds, you can have more water than what is supposedly humanly possible or physically possible be held in what I mean is it's held as water vapor. It doesn't condense beyond the normal physics limits. There's certain pressures and things like that can happen in the clouds that can cause that. But the more interesting aspect is what's called supercooled air. Now, supercooled air means that we all know that water freezes at 0 degrees Celsius or 32 degrees Fahrenheit. But in supercooled air, it could be -4, -8, -10 degrees Celsius, 20 degrees Fahrenheit, and still it's not frozen. Certain conditions happen that cause that. And believe it or not, you need those conditions to make snow. The way snow happens is when there's enough moisture, it goes from a gas, water as a gas, into frozen. It doesn't go through the liquid stage. Something happens, usually it could be what's called hydroscopic nuclei touches the water vapor, which is just a little dust speck, or some other factor causes supercooled, which means it's cooled below 32 degrees, but it's not frozen, to instantly go to frozen without passing through that liquid stage. And that's how snow is created. And that's why there's the signature to know that happened is the 6 sides to the snowflake. So just a little trivia thing with how snow is actually made. When you understand all the different aspects of water, you really understand how it's really a miracle that God gave us. There's so many different aspects of water that are just so fascinating. For example, that it's more dense at 34 degrees than at 32 degrees, or more dense at 1.5 degrees Celsius than at 0. That means a whole lot of things for a whole lot of different reasons. It's why rocks will split with ice. There's all kind of different things that are so cool about water.
I don't know whether you did watch it, Rich. It wasn't one of mine for a change. It was actually this guy who'd gone up in his microlight, and he was testing. He took a little machine with him to show like the oxygen levels, and he wanted to, because you're not supposed to go above, is it 15 or something? And he went up to 18, and there was still air there. He wasn't a flat earther or anything. He was just testing out this piece of equipment. He wanted to see if it worked. And then he thought, well, to be at this height without proper oxygen is not very good. So I'm going down. But up there, it was still registering oxygen when they've said there's no oxygen up there, but there is.
And how?
Well, yeah, it's really changed, I mean, but it wasn't showing that. It was still showing healthy oxygen at 18,000 feet.
Wow. Yeah, well, it's like we've talked about before. How much, we know they lied to us about so much, but how much is a lie? NASA spent a lot of money, I think it was 6 or 7 years ago, to go up on Mount Everest. And the reason for that was they were taking radiation readings. And NASA even said, we want to see what the radiation readings are at this altitude. It's like, well, you're supposedly went to the moon and you don't know what radiation is at 7 miles up. So, when you really think about some of the things that go on, you realize that you've been lied to about a lot of stuff.
Well, they were probably doing something else, Rich, because they like to say one thing and do another, don't they?
Yeah, absolutely.
It's probably a smoke screen for the real thing they were there for.
Well, I still absolutely believe that most of NASA's work really is underground military bases and different things like that, not up. They have you look up so they can do everything underground.
Not out in space, under the earth.
Yeah. It's a hollow earth because of their tunnels.
Yeah. We've been going for nearly 3 hours now, Rich.
Well, I would say, if anybody has questions, we can answer those. If not, we could end it.
Yep. Anybody in the chat room, a question for Mr. Thrive and Survive? Yeah, so no, that was for Astral. So your mind's spinning a bit now. You realise that you can do more tests, Rich.
Yeah,
and
yes,
brainstorm.
I'm open to anybody else too that has any ideas. I might not be able to incorporate it, but it might spark. Even if I can't do it, it might get me thinking about something else. Wow, I don't know how you can even read that. The chat is just flying by what I'm seeing anyway.
Dale says, Salted Cedar says, while you're in Denver, check out the airport where all the tunnels meet.
Yeah.
Yeah, I'll be at that airport, so no doubt.
Take loads of pictures at the airport, yeah. See what's going on.
So is this the one with the funny murals and things in it?
Murals?
This is demonic stuff all over the place.
Yeah.
What do you say, Karen? Funny murals?
Yeah, I can't remember. There's one, isn't there? It's
That's Coronation Street. That's Hilda Ogden.
Okay.
Yeah, there's all kind of occultic everything there, pictures and statues, and I understand it's pretty creepy, especially if you're tuned into that kind of thing.
Ian says, thanks for your insights, Thrive. Barometric pressure, you on to something there, fella.
Well, thank you, Ian, and I appreciate Ian's help. He's been helping me on the backside with some stuff.
Good. I'm glad everybody's helping, Rich.
Yeah, I mean, the more we get people to lend a helping hand, so to speak, the more we're going to plow through, the faster we're going to plow through all the lies, and maybe we can do our own encyclopedia of the truth.
But Patricia says, Billboard Gathering is on Wednesday around 3 p.m. Follow FEP podcast for last minute details and transportation.
Okay, that's from Dave. All right, thanks, Dave.
Yeah.
I'll be there. I'm coming in Tuesday. Now, is that his podcast, the FE podcast? I'm not sure what that is. I'm writing
the Flat Earth podcast. You can just you've got a podcast app on your phone. Just go on that and then type in Flat Earth Podcasts, and you'll find it. It's a good channel. If no one's listened to that, you check it out. It's really, really good.
Okay, very good.
Cool.
Rich, can you see the moon phase change in one night? That's a good question. I guess you could take photography when the moon rises and then take the photography towards the end of the night and see if it changed. I've actually thought about that. I wonder if that's, I mean, it's obviously supposed to be growing at a steady rate, but I know it's not a steady rate. Even science says that, just nobody talks about it. So I don't know.
Ditra says, I think we'll have a bus from the hotel to the billboard. The billboard goes up this coming Monday.
What is the billboard? Billboard goes up this coming. I think we'll have bus from the hotel to the
Going to
billboard.
be
Oh, that must be, okay. That must be the location where we're meeting.
Yeah. Any questions for Rich? Now is your time.
Or forever hold your peace, right? Would anybody be interested if I did a different channel? Politics and just these different subjects that aren't directly in the flat earth? Just curious.
Rich, you are your own man. And if you choose to do knitting on a Friday afternoon with Mr. Thrive and Survive, you know,
that would be
do
interesting.
that. No, but you know, I mean, yeah, you don't need to ask anyone's permission,
It's
brother.
a billboard to flat Earth, by the way. I thought it was going to be just flat Earth. I just
okay, gotcha.
Yeah, maybe you do. You have a channel, you know, Saturday, whatever it is, with Mr. Thrive and Survive. It's up to you, isn't it, Rich?
Yeah, I guess I just, you know, but if nobody's interested, then they're not interested. Then maybe it's not worth doing. Bruce Thompson, can someone explain the cycles of the moon on flat Earth? What lights it up? My theory has always been that it's a capacitor, or works like a capacitor, where it charges and discharges, and that we see sort of like take your hand and cup it and put a flashlight underneath of it, and the light comes through your flesh, even through your, you know, you've got bones there and everything. But that's one theory. The other theory is probably even stronger. It's where Dave Marsh's work even showed, where he exposed the moon, and then what actually looked like the moon was beside it, that image, if you know what I mean, Karen. So shows that it can be projected. Then we have that eclipse picture that someone sent me from Hawaii that shows. In fact, I'm going to pull that up. Hopefully, I can find it real quick. That shows what looks like a full moon just before a solar eclipse took place. It was right under or to the left of it. And the focus has always been the orientation of the moon. And there's been arguments back and forth. No, it's in the right place. No, it's not in the right place. It wouldn't move that way anyway. But that's not really the main point now. That again, that was early on in my flat Earth career. So I wasn't asking the right questions. The right question is, why can we see that image at all?
Did you see that one? I'm sure Joe Hill, he actually sort of put it on only a few months ago, or when the eclipse came to him, he didn't see the eclipse, but he saw the shadow of the eclipse. This big shadow went across the sky. And when that was happening, the sun went really weird. You know, it went a different color, like you could see. And then when the shadow went, the sun went back to the sort of more brightness. He just had a shadow.
No, actually, I haven't seen that yet. Okay to share again, Karen?
Sure, I'll send it to you again then, Rich.
Okay, thank you. If I get busy with stuff or whatever, things will go by and I miss them. I think, oh, I'm all caught up, and then there's a video or two I might miss. All right, watch this. I can get back to it. Okay. This is in Hawaii. Forget about the orientation. It doesn't matter. This actually should be flipped left 90 degrees, I think, but it's not important. Here's the sun, and it was just, I don't know, half hour before an eclipse. Here's the moon, and these are pine trees or whatever they are over there, and we're seeing actually a shadow of the trees. He said he wasn't shooting it through the trees. It's just a shadow of the trees. Remember, this is photographic film, so it's very sensitive to differences in light, especially when you're facing the sun. But here's the thing. Why are we seeing the moon at all just before an eclipse? And to me, that can't be answered. Not in their model. There should be no light here. And somebody will say, well, it's Earthshine. Well, you never, ever, ever see this, do you? You never see this when it's close to the sun. And you can even see that there's darker parts and lighter parts, just like we see in the moon. And someone said, oh, it's just a double exposure. Well, he never took any pictures of a full moon. So he said all he did in this whole thing was, and here's the actual eclipse. See, at first we were talking about which path, and with the latest videos you've sent me, Karen, I'm going to be doing a video on those. The eclipse path, that could change that drastically depending on your location, and it doesn't have to be that far apart. When I see stuff like this that are actually filmed through telescopes and things like that, cameras, and
that's Joe Hill that did that one, yeah.
And then we see these cartoons that NASA passes out or that puts up that people like BP Earthwatch he thinks he's actually looking at the sun. It just blows me away. Oh yeah, I got your link, Karen. Thank you.
Oh, that's a different one. You should watch that one, Rich. That's when it's eclipse, and then it goes across one way, and then it's red, and it flips back over the other side. You'll love that one. It's not mine, obviously, but you'll love that one. Anyway,
yeah.
I'm looking for Joe's one.
So anyway, this was taken 7/11/1991. So before the digital age. So there's no there's no hidden tricks or anything like that or Photoshop. In fact, somewhere in here I've got the actual, because people were like, it was manipulated. Of course. See, anything that doesn't go along with their model is manipulated. They were 35 millimeter slides. I don't know how many people are old enough to remember that, but I remember that. You would take your film and you would go to usually a drugstore or something, or they called them 5 and dimes here. And searching for that. Come on, where is it? And you would have them develop it. And you had to wait like sometimes 3 or 4 days before you got the film back. Trying to find where he shows that it's a slide. He actually holds it up so you can see it. Now see, this explains this path here, where the shadow's going right to left, and then it exits left to right. For you guys in the chat, you may want to pay attention to that video coming up that I'm going to be doing on that, because Karen sent me some stuff that's just absolutely amazing, where the shadow in Phoenix and wherever yours was in your video, Karen, the one you sent me anyway, I know it's not your video, but the shadow's coming in from the top right, and it was here in Phoenix, but yet in Mexico, not south of the border, just a few hundred miles south of here, the shadow.
Northern Hemisphere.
Yeah, still in the Northern Hemisphere. Yes, the shadow came in from 2 o'clock in Arizona and everywhere else in North America, and just south of me in Mexico, it came in from 10 o'clock. And that's impossible in their model too. And you would say, well, maybe it's a mirror, but it's not a mirror either, because I don't know. I'll have to go back and look at it, but here we go.
I found it, by the way, Rich, just to say the video for Joe Hill's one is no penumbra. He didn't get one. He didn't get any of that. So he just got the shadow of the eclipse.
I don't think there's ever a penumbra, ever. I really don't.
But the other one you'll really like, because this blood moon, the whole thing just sort of flips off.
Yeah.
Yeah.
Yeah, I'm gonna, and I think I'm gonna put that in the presentation in Denver also. But here's the slide right here, and I covered it up right here just to keep the mystery going in the video. But he holds up the color slide, the original, and so this is a lot different than the modern age. See, there it is right there. It's a lot different than the modern age of being able to go to online and put it in Photoshop or whatever. So these things are not manipulated at all. This is the original. It's on a slide. It's not even a print. So it's like looking at a negative. You shine light through it and you get this. But that's impossible. It's just, I mean, how are you getting that much light in front of it? And although, like I said, during crescent moons and things, you would think during a crescent it would be much easier to see, but we never get enough detail to be able to see the seas and the light parts of the moon, what they call the seas. We just never do. So this to me is the name of the video is an impossible photo of the moon, and that to me is what it is. In their motto, it's impossible. So. Anyway,
amazing that the capture the clouds. It's like a dragon or something. It's going to eat the other moon up.
yeah, these are shadows from a tree.
Right. All right. Okay.
So if I rotated this left 90 degrees, it would make more sense.
All right. Okay.
So. And
No
that was that's what everybody was worried about in this, and to me, that's not really the point. So, I guess we could go with any more questions.
Well, yeah. If you want to finish now, Rich, that's okay, isn't it? You know, it still takes out of you, doesn't it, when you're talking and explaining things for a while?
Yeah, you've covered absolute masses of information and different stuff tonight. Masses.
That's what happens when that's what happens when you have no subject in mind.
Well, we've been thinking for weeks now after what you've been saying today. Seriously.
Yeah. Plus, Rich has done another thought of experiment today as well. Another one.
Yeah, I don't see any way around a barometric pressure proof.
Hey,
of
Rich,
course, there will be.
The hangout down, Rich.
What's that?
The hangout's up on your picture.
Oh, okay. Let's do this.
Hey, that's it. You're back.
Oh yeah, I see what you were worried about. Whole thing. Why did that come back? Interesting. I deleted that off.
Yeah, I wasn't going to say anything, Rich.
Well, the good thing is in this case, my address bar isn't wide enough to show it all.
Oh, that's good then.
Yeah, you don't have to worry. It was cut off at the end.
Cool. Whew. I was a bit worried. I didn't say anything. Rich, it's been amazing as always. You know, you're just I don't know, you're such a clever person as well, and it's always great listening to you. And yeah, the things you think. Maybe that's being part of being a weatherman.
Could be. I don't know. But like I said, going back to what I was talking about at first, if anybody is interested in me mailing them the scale and the weight, and then doing, helping to contribute to the experiment with the weight of different objects at different locations, I think that might be the best way to do it, is just mail this equipment around, have them mail it back, and then we can get all kind of different data points. Maybe we can start making sense of why we do get different readings at different areas, and start to put that together, because we're being told a lie there too. I think we're being told a partial truth with that is the best way to put that.
Well, I think they're always telling you a bit of the truth, and then they just cover it up in a lie. And I mean, those articles, it was artists that actually found those, but the NASA documents they released, he always said flat plane, and then they turned us into a ball. So they told the truth, covered it. Well, they were talking about the truth, and then they covered it up with the lie.
Yeah, absolutely.
Anyway, It's been an absolute pleasure as always, Rich.
Well, thank you for the opportunity. I enjoyed myself. Thank you, Astral. You too,
Yeah,
Patricia.
Yeah, it was actually a night with you for a change, rather than you listening to other people.
Yeah, thank you, Rich.
And thanks,
Yeah.
thanks for the chat group too. The questions.
Yeah, we always enjoy having you on Sun and Moon. And yeah, thanks to everybody in the chat room. We're back, I think, Sunday actually with the Boogeyman channel. But anyway, it is morning, afternoon, evening from us, and to everybody on the panel. And thank you so much, Rich.
Yeah, as I said, thank you. Thank everybody. Bye.
Yeah, thank you, everybody.
Bye, everybody.